Hello guys. Guys, you are able to hear my voice. Just raise your hand. Yeah. Okay. So I will present my screen. So just confirm with that. Okay. Try to share my screen. Screen is visible, right? For your. Okay then. Okay. In the last workshop, we discussed it up to the ASIC flow. Like what are the things we discussed like as a quick recall? So here we discussed about like introduction to semiconductor and VLSI industry and what are the different domains is there in the VLSI industry as a front end and back end. That what are the different job roles is there and everything we discussed like where we can see as in the career with respect to the salary or position and everything we saw. Then we discussed about the digital design fundamentals for physical design perspective. Next is nothing but we discussed about this CMOS fundamentals also as well as ASIC design flow, like how this, what is the chip design life cycle. Also, we discussed in this, and with respect to the Verilog, what is the basic knowledge as a PD engineer you're supposed to have. So, with the help of that basic knowledge, what we can able to do and how we are going to be analyzed, like how it will going to be impact on our PD. So, up to here we saw on the last session. So, today we will go with the inputs of the PD along with the synthesis fundamentals and everything. And today's main agenda is like parallelly we are going to be see both. For example, first if I discuss the theory about the synthesis means, then parallelly we are going to be see the both like a practical also about the synthesis. Next we are going to be jump to the inputs. Then we are see the parallel inputs like what are the inputs we are taking for the design as well as some lib files and library files. I don't know how it will going to be look and everything. I'm going to be show you people. Understood? So this is the way today's session will going to be. Move. So please be alert. And if you have any queries in the last half an hour, we'll give you the time to ask the question. Just make a note of all the questions. Okay. Whatever the doubts you have. So in the last session, up to here we discuss. So from today's session, we are going to be discuss from the synthesis. Okay. So before that, we want to learn that what are the inputs for the PD, because if we know the inputs for the PD, then only we can able to understand like what is the synthesis and how the synthesis will going to be work and everything. So for the first, we will cover the inputs for the PD, then we are going to be cover this particular synthesis. Fine. Okay. So for coming to the synthesis, synthesis is nothing but it is a process of converting here. Synthesis is a process of converting RTL Verilog code into a gate level netlist using the standard cell libraries while meeting the target targets such as like timing, area as well as the power requirement. So this is nothing but a synthesis. But here you want to learn what you want to learn like first of all, what are the inputs we are going to be taking for the for the synthesis? Like inputs. Okay. Next, like, and what is the information present in that inputs we want to know first. Okay. So you want to know first the what are the inputs you supposed to take to perform a synthesis. Next, what is the information consist of inside the input file. Next thing is nothing but how these input files are helpful to convert your RTL into gate level netlist. That means what is the role? What is the role of them? Like for each and every input file have the different things. Okay. So that is the thing which we want to make sure. Can you confirm like voice is audible and screen is clear, right? Hello, ma'am. Guys, everything is clear, right? Fine. Okay. So these are things first we want to know. Okay. Next, while coming to the synthesis flow, as we are taking the RTL during the synthesis process, as we are taking the input as a RTL, and during the synthesis process, we are going to be get the output as a gate level netlist. Then this is the gate level netlist which we are going to be hand over for the physical design. Okay. Synthesis is here acting as a bridge between front end and back end. Why? Because of without this gate level netlist, what is the output we are extracting from the synthesis? We can't perform the PD. That is the way the synthesis is the process between the bridge between the front end and back end. Okay. In this synthesis, like as we are taking the RTL along with the inputs and all, what exactly this synthesis will going to be do? That is nothing but translation plus logical optimization and mapping. And what is this and all? We'll see that. Okay. First, we will cover this, what are the inputs is there and what are the information inside that all the files. Then again, we will come back to this particular image and we will going to be, then we will going to understand like what is that exactly. So same thing, once it is done, we will jump to tool. Okay, first thing is nothing but RTL. What is our first input? First input is nothing but a RTL code. So the RTL code is nothing but like register transfer level is in the form of the Verilog or VHDL or .sv. Already we discussed this. And next is nothing but like example is like this is a basic syntax for this one. Okay. Next. So what is this gate level netlist? Next question is nothing but a gate level netlist. What is the output we are going to be get? So a gate level netlist contains the standard cells such as that means what is the information consist of this inside the gate level netlist file like .v file? That is nothing but this same standard cell information only. Either it might be sequential or combination or whatever maybe or any logic gates. Okay, but it consists of only the standard cell information. So from where we are going to be get this standard cell information with the help of the .lib file is one of the library file. Inside that the all the predefined standard cells will going to be present based upon our netlist, like based upon our RTL code, the tool will going to be fetch which is the proper one and everything. Next, physical design perspective. The gate level netlist is the main input for the PD. That is the first thing we can able to tell. And this is the basic flow for the RTL to gate level netlist. Next. So here we want to take the certain inputs, right? So first input is what? So here the first input is nothing but like RTL code. Okay. RTL code is your first input. First input is nothing but RTL code and second input is nothing but like .lib. Okay. Next is nothing but .t technology file. Is the two things. What is this information is directly I will show in the tool itself what the what is the lib file consist of as well as the .tf file consist of. Next is nothing but a .sdc. SDC stands for Synopsys Design Constraints, or we are going to be called standard design constraints also as well as Synopsys design constraints. Both ways you can able to tell. Next, it comes here. You want to know about like what is meant by constraints. What is the general meaning of constraint? Constraints is nothing but the inputs you are going to be called. So, what are the various names for inputs until we saw? One is like constraints. Okay. Next, vectors I told with respect to the DFT format and inputs. So, the meaning of these three things is same with respect to the PD like VLSI. But based on the stage to stage, it will going to be vary. As well as same inputs. That is nothing but in during the specification file, we are going to be call it as a spec. What is the inputs is given by the customer. Like stage to stage, the way of calling the technical terms will going to be differ. And whenever you are going to be speak with respect to the stage, you want to speak with respect to the particular technical terms. Okay. Next, constraints tell the synthesis tool how to design should be operate. That means here, this is the thing it will going to be tell. A clock definition. Clock definition means like this is your clock, right? So here, what supposed to be the name of the clock which you defined in the RTL code and what it want to replicate as a for our reference purpose as well as what supposed to be clock period of this one. This is the one thing. So like this, all the things will going to be defined in this particular create block. What is the command is nothing but like create underscore clock is the command. Here first we are going to be give like switch name. So some name we are going to be give like CLK. It will going to be replicate to us in the PD. Next, switch period we are going to be give. What is the period? That means here to here if you want to take 10 nanoseconds means 10 nanoseconds. Okay. Next is nothing but within the brace get port. you want to give as a get port. Here you want to give the port name which is defined on your RTL code, clock name of your RTL code. So like this you want to give. Same thing with respect to the input delay, output delay, and everything else. Input delay, output delay, false path, and multi-cycle path. So these are the two important things. Here, false path is nothing but a path which is physically present in our design, but it won't do any impact. Okay, for example, for this path, false path, so how to identify the false path means we have the technique called as a path sensitization. Okay, so that means see, for example, this is my inputs. Okay, this is my some logic gates and all everything is there. For example, there is a path, and here I have one OR gate. Okay, so there is the first input, and here will be the second input is going like this. The input is going. So we know like A, B, and C. So if you want to get an output at here, you want to get this both inputs. Okay, then if you think like 2 nanoseconds, 1 nanosecond, 2 and 2 nanoseconds is the delay. That means at what time the output want to come? After the 7 nanoseconds, we are going to be get the output actually based on these two inputs. But there is a thing called as a controllable and non-controllable inputs. For AND gate, if one input is 0, output by default 0. For OR gate, one input is 1, output will going to be by default 1. For example, here if I give the 1 as a input, okay, then by whether I want to wait for this input, no need. Because if the one input is 1, that is enough for me to get an output. That means within 2 nanoseconds only. But whether this entire path will going to be present in your design, but is there any physical impact, like functional impact on that particular path? No. So those are nothing but a false path, which the STA tool won't analyze the timing for it. Okay. Next is nothing but a multi-cycle path. That means actually what I explained to you people. So in the first clock cycle, if you are launching the data, supposed to be captured at the second clock cycle. If intentionally to meet your design requirements, we are going to be guide to the tool like it's supposed to take more than one clock cycle. The launching will going to be happen at the first clock cycle, and the capturing will going to be happen at the second clock cycle or third clock cycle, whatever may be. Okay, so that is nothing but a multi-clock cycle. Okay, so there is nothing but a multi-clock cycle. Next, for example, below I gave the commands. Like what is the command for create clock means create clock switch period 10 and get port. So here is the command for the create clock. Like this, here we are creating a clock with the 10 nanoseconds. Okay. With respect to the PD perspective, how we want to analyze this HDC constraint, like if the constraints are not proper, if the constraints are not proper means then it will going to be affect the timing analysis. While we are analyzing the timing, it will going to be affect. We are going to be end up with the timing violation. So that is the where we are supposed to ensure the constraints, whatever the inputs we are giving to the tool also, it's matter. Okay. So here you can able to see that exactly how the script will going to be look. Okay, this is the where you are going to be seen now in the tool category also. Like this, I wrote for the we have that scripts for everything. I'm going to be show and I'm going to be explain. Once the theory is done for synthesis, we are going to be jump into that. Okay. So here the timing constraint define the target performance. Here we are defining the frequency, setup requirement or the whole requirement. Example is this, and main goal is like all the paths in that particular design supposed to meet the both the setup as well as the whole. If anything is not meeting means then it will going to be called it as a violation only. Okay, physical design perspective. Timing constraints directly affect the placement, CTS, timing, and routing and timing closure. Why means, see, if the timing constraints is not proper, you don't know like how much wire length it want to take between these two things. So here the routing will going to be impact. Like at what distance the two shells supposed to be placed. Then the placement will going to be impact. If the clock is not distributing properly, at the stage of CTS also will going to be impact. Whenever we are analyzing the STA like timing analysis, then only it will going to be end up with the violations only. So this all the issues we are going to be faced. If you are not bothering about like what is there exactly our HDC constraint, whether the constraints are proper or not, if you are not bothering with, then it will going to be affect this all the things. Okay. This is a basic script which we can able to see. Like output load capacitance, input transition, this is the input delay, output delay, and load. Okay. Here, what is my input transition and output load capacitance means how much time it want to take from to change the state from 0 to 1 and 1 to 0. This is nothing but transition time. And capacitance is nothing but this is the thing, how much time it want to take to charge and discharge here. For every gate consists of the load capacitance. So how much it can able to store has a maximum point. So that is the thing here. I think it was clear. If you have any doubt, just make a note of them, everything. We're going to be see that, okay? And this is nothing but a optimizations. Okay, here here I'm representing with respect to area as well as the power. Two optimizations as well as the timing. Three things will going to be happen actually. So here, when the area optimization will going to be happen in the synthesis, when the normal power and timing optimization will going to be happen in the synthesis. If that is the case, synth can be performed in two ways: logical and physical. Okay, logical and physical. Here, what is the difference among them means here it will going to be optimized with respect to area also. Here only timing and power. Here also timing and power will going to be optimized. But along with the both, the area also will going to be optimized here. That is the one more thing. Then is there any difference in the tool, like what are the tool we are going to use in the real-time instruments? There is a no difference. But the way we are going to be invoking the tool is a different. For example, DC shell. DC shell is for logical means, for physical DC shell topo, topographical mode you are going to be called. Then it will going to be supported this one. If you are using this and if you are trying invoking the tool in the DC shell, if you are trying for physical synthesis, it won't work out. So like this. So we want to learn the many things with respect to these things and all. So during our course time, we are going to the deeper. Okay. So like this. Okay. Here we're coming to the area optimization. The area optimization reduces the total silicon area occupied by the design. Because of this thing, the cost also will going to be reduced, as well as we can able to increase the functionality also. That means this much of thing for four modules is happening means if you reduce the area to like this, with the same area we can able to include still two or three more modules, like two or three more extra functions, operations that you can able to do that. So there is the one more opportunity, advantage in the area optimization. Next is nothing but what is the advantages among them. That means benefits means smaller chip size, that means easy to carry for the such kind of electronic gadgets, and lower manufacturing cost also. Techniques like this is the two technique, these are the three techniques which will going to be used to optimize this area and everything: logical optimization, resource sharing, and cell sizing. Okay, next is nothing but a PD design perspective. Smaller area generally means lower routing complexity and lower congestion will going to be affected. This is about the area optimization. And then while coming to the power optimization, this is the two types of power already we discussed in the CMOS. So to reduce this dynamic as well as the leakage power, we are going to be use these three techniques. Already we discussed this thing in the last session itself, like clock gating. So clock gating indicates like this one AND gate will be there. This is connected to CLK, and this will going to be connected to enable signal. So always the clock is coming to input here as a one. But whenever the input next input will come, based on that only the output will going to be decided, right? Like that. Whenever the enable is one, then only the gate will go into the particular whatever the sequential module is that it will going to be get some clock. If not, it is a zero. It won't get any clock. That is nothing but a clock gating. So these are all the things. Well, coming to the advantages, that is nothing but a longer battery life, lower heat generation. With respect to PD perspective, this is the issues will going to be occur. We have one more slide, that's it. Then we are going to be jump into the tool. Okay. Once our synthesis is done, then what we want to do? It is a case. Then we want to analyze the timing report and we want to check the slack and all. It will going to be used for the timing. Area report we want to check, power report we want to check. Okay. So, and what are the challenges we are going to be faced during the synthesis? Okay, if synthesis is not done properly. First thing is nothing but there might be a chance for setup and whole timing failures. First. And next thing is nothing but area. If the large number of shells are increase is there in your logic means, for example, to perform a basic logic, it is taking more gates. Then it will going to be end up with the area issue. Next is nothing but a high power. Excessive switching activity increases the power. Okay. Next is nothing but a constraint. If the any SDC constraints is not proper or any other inputs, whatever we are giving, it is not proper means it will going to be end up with the issues in the synthesis only. So not only the performing the synthesis is important, like whatever the inputs we are taking and how we are going to be performing the particular stage also matters. Okay. Okay. Now we'll jump into the tool and we'll cover this synthesis. Then again we'll come back to inputs of the PD. Okay. Okay. While coming to here, in the two ways we can able to perform the synthesis by using the two tools as per the synopsis. Okay, as per SYPS. Okay. As per SYPS, we can use two tools. One is like FC, Fusion Compiler we are going to be called. Next is nothing but DC, Design Compiler we are going to be called for synthesis. Okay. The same thing, it will come to the PNR. That is nothing but ICC2 will going to become here. The combination of these two will going to be work and this is a common tool. Okay. As now, I will give you the overview of this thing as well as these two tools also for you people. Already everything was implemented, blocks are saved. So here, as a main objective, I will show you all the scripts and I will explain you. And I will show you like how the blocks will going to be look and how to view how what are the things we want to see in the block in the each and every stage. I will going to be show you people. Okay, this is the main objective what we planned. Why? Because of if I run these particular scripts here in front of here, it will going to be take more time where we can't cover all the concepts. Okay, that is the main thing. So first of all, as a PD engineer, before starting the project, like before starting the any design, you're supposed to know the two things. Okay. First of all, you want to know what tool you are going to be used. What tool you are going to be used for the particular design. Okay, next, you want to go through thoroughly about this. You want to go through the tool, like what are the things is available in the tool and what are the things we can able to do, up to which extension it will going to be support for the design. And the next is nothing but, so you want to create a directories in such a way that it's supposed to be professional like. For example, now I'm going to be start one design called as a USB. Okay, this is my first directory. How I can able to create the directory with the command of mkdir. I'm going to be use this command and I'm going to create this directory. Inside that, I have the two parts. First is like synthesis is there. Next is nothing but PNR. Inside that again I want to create two subdirectories. Okay. Next inside the particular thing here to store the all the inputs we want to create one directory called as a constraints like this or you can able to create it as the inputs. Next, to store what are the reports we are getting. That too, we have one more directory. Next, to store the RTLs, what are the input files we are what is the input files we are going to be used. For that also, we want to create one more directory. And these are things which we are going to be save here. What are the run scripts is there? What are the scripts we are running? That scripts here we are going to be stored. Here we are going to be invoke the tool and we are going to be using. And here this is the important thing for the PD engineer. What is this? This is nothing but a logs. What is the use of that? So whenever you are running or whenever you are going to be working in any design, uh, whenever you are going to face any issues, okay, as a fresher or as experienced candidate or whomever may be, so whenever they are working, if they face any issues, if they are unable to resolve that particular issue, then what will going to be happen? Like whenever you are going to be approached to your team lead or any higher position, like the person who know how to fix that particular violation or other, then we are going to be show this particular log file. Okay. So from this log file, they are going to be analyzed like where exactly the error is coming. From that, what are the try you gave already. Based on that, and as well as based on that error, they are going to be guide you. They won't fix in the industry and all. So and they won't have the enough time to sit with you again. You are whenever you are running that particular stage and all. Okay. So just you want to share this documentation. That is nothing but a log file. So this is the importance of this creating the directory for the just a synthesis. Okay. I hope it is clear for all. Next. Next is nothing but like now I will show you the scripts. And while coming to the Fusion compiler, right, first we will see the Fusion compiler. So Fusion compiler have that 7 stages. Okay? 7 stages. That means up to the placement it can able to do with these 7 stages. Okay, there is this internal 7 stages can be done with a single command called as a compile fusion. That is the advantage of this. Okay, next is nothing but as usual like CTS routing, which we want to do like individual like separately. So what is these 7 stages? So initially, if it will come to the synthesis, one is like initial map and logic opto will going to be do the synthesis here. Okay, whenever we run these two things, then it will going to be perform the synthesis in the FC. But while coming to the DC, it is different. Okay, here also same procedure, but the command is going to be different here. That means in the FC we are going to be use the command called as a compile fusion. Compile fusion. If you think switch from initial map to initial map, switch to initial map. So like this we are going to be use the commands. But there we are in the DC we are going to be use the command called as a compile ultra. We are going to be use the command called as a compile ultra. This is the case. Uh, Okay. So now we'll directly jump into the tool. First of all, I will explain you the scripts. These are the scripts is there, which I have stored like basic input files. Okay. First thing is nothing but a setup file. What is the setup file? Why it is required? What is the importance of this thing is like. So for example, in the real-time example, if you are planning to prepare any food or anything else, you need one database, like you need one container to store that all the things, right? For here, we are going to be create here also in the VLSI also same thing. You need one database. Okay, like this. You need one database. This thing we are going to be called it as a dlib. So design library we are going to be called it as in the form of dlib. So where whatever the inputs like this RTL and this lib file, okay, as well as this whatever the technology file and everything will going to be stored here, all the inputs. From here, we are going to get the outputs. What are the resultant we are going to be get. Here in this setup.tcl file, first here I am setting this path of the particular technology file as well as this NDMs. Here NDM stands for new data model, which consists of the complete information of the particular design. So here coming to the technology file, what is this technology file? What information it consists of? And everything means see here. This is the variable name here. What I declared tech underscore file. This is the value for the variable. Whenever I'm creating the whenever I want to give this technology file name, so instead of this giving the entire path, just I will give this one. Use this one with dollar tech underscore file. If I give me the same value will going to be replicate here. So this is the thing. Here we just I'm setting the reference library as well as technology file in this particular thing. Next thing is nothing but like run.tcl file. So here we have the file called as a run.tcl file. Okay. So here what are the thing is there? Here just I am going to be calling that setup file there here to here particular thing. Just here I am sourcing the setup here. So what is the use of this echo means whatever the information is there inside this setup.tcl file, just it want to print there. That is the use of this echo. It was clear? That is the use of this echo. And just here, whatever the setup file before we saw, the same file it here it will going to be sourcing. Next here we are going to be create the library. That means create library switch technology. Here see, here I can able to give the path like this or whatever the name there I set it for the variable like text path. So I can able to use like this also. Like this also I can able to use it. So in the both, any one thing we can able to use. Okay, next is nothing but reference library. Here, see, I am using with the variable name only. That is the way I showed you the differentiation. Either you can able to call that particular file with the path, or you can able to call with the variable substitution. This is the two ways. And next is nothing but like analyzing. So here we are going to be using the files called as a .sv files, system verilog files. What are the things we are going to be use? Here we are going to be using the command called as analyze. So in this analyze, we are going to be verify about the syntax of the particular logic. Verilog also a case sensitive. That is the way. Okay. Next, here we are going to be elaborate. In the elaborate stage, what will going to be happen like exactly? So whatever the top block is there, whatever the top blocks is there, just it will going to be show you the top block name. What are the inside the top block? It won't replicate anything else. Just it will going to be show the top block. Whenever we run the command called as a set top module with this particular module name. Yesterday I told you the module name of the Verilog code, right? That same name here we are going to be using. So if you whenever it will call then it will going to be show you like which is the top block and these are the sub blocks like this in the form of hierarchy view. You are going to be called. Here, what is the current block you are going to be work? It will going to be give this get blocks. The same time, this get model will going to be give you like what are the different RTLs is there inside this top block. It will going to be keep. Here, I'm just loading the UPF HDC file, and here I'm creating some. And here I'm providing the voltage. Why? Because of as I already told, like during the four pan and power pan, the power is important to turn on the any transistors. So here, what is the voltage we are going to be giving? The voltage is nothing but like 0.95 volts. I am going to be providing for the two. It is the case. Next, here there is a two files is called as a parasitic files. We are going to be called. It consists of RC information. What is meant by RC? If there is a metal layer consists of resistance and capacitance per unit length. That all information will going to be present here. So same thing we are going to be here we are sourcing the two files. For the further, whenever we are doing the timing analysis, then this delays will going to be important. Why? Because of if this is a path, if you think, so this is nothing but a CL you are going to be called. CL is nothing but a combination logic. Okay, like here to here, how much time it is taking? This will going to be depend on this particular RC value. Okay, this thing will going to be depend on RC value. Next, here we are going to be checking like whether inside this library the parasitics are read properly or not. And here is the thing we are doing the synthesis process. This is about the synthesis in the FC tool. So this much of minimum setup we want to do before starting the synthesis. Okay, because it is the first stage. So now what we will do, like just I will invoke the tool and I will show you. Okay. So here just I will invoke the tool. So how to invoke the fusion compiler tool? The command is nothing but a fc underscore shell. Now I told you like whatever the thing, log file is the one term. How to give this log file, how the data will going to be stored into the log file means. So whenever you are invoking the tool, then you want to give the, then you want to create one log file first of all here. That is a directory where the log files will going to be stored. Okay. So here what I am doing like to GUI. So what is the full form of the GUI means? Graphical user interface. Or we are going to be called in the short term called as a GUI, we are going to be called GUI in the technical thing. Okay. So here, this is nothing but a pipe. Okay. And here I'm giving the path to this particular. Before that, you want to use. Okay. Here you want to use this path. Where is my log directory? If I go one step outside this particular work directory, so before that, you want to know like what is your current working directory. That is nothing but a PWD. So present working directory. It will going to be here. So from the home user 21 inside the desktop, this is your path. Okay. If you want to go back to from this particular path means CD is the command you want to use. If you use like double dash slash, that means go one step backside. Okay. Go one step backside. This is the way. Now now I want to see like what are the directories is there, what are the files is there inside these directories and everything means one thing actually we can use like this first LL like list this all the directories we are going to be get. This is the contents of this particular thing. From that, again, we want to go inside this. Say again here, we want to go inside the constraints. Again, we want to check like what are the files is there inside this. So instead of that, what I'm telling, like, so there is some Linux commands. Okay. So here there is some Linux commands. For example, if I use a Linux command called as a tree. So here, see, I can able to see like instead of going inside that particular constraint file and everything else, just here I'm using the single command called as a tree. See, whenever I will use the tree is the Linux command. Tree inside the constraints, this many files is there. Inside the logs, no files. Inside the reports, there is a power plan is the one thing. Inside the RTLs, there is a 3 RTL. Inside the script file, there is a 5 scripts is there. So like this, here you are going to be get very clear information. Okay, like this, all the things we supposed to be learn. Okay, as a PD engineer. Without that, without these things, it is difficulty to analyze that all the reports and everything. Okay, so here now what I will do? Just now I will go to this workshop to the work directory. Just cd which directory you want to go. You can able to give that path. Okay, next. So now here I am going to be invoke the tool. Here I am going to be invoke the tool. What is the date like? 15.log. That means with respect to today's date. So this is a way. So so like this, it will going to be start. So this is nothing but your FC window. FC shell will going to be work. You will going to be look with respect to the GUI mode and everything else. Okay, next. So before starting any EDA tools, you want to know about like what are the taskbar things is there. Like see, if you go to the file, inside the file you can able to create a block. You can able to open the pre-existing block, or you can able to set up a library, or creating a library, or open a library. Like these, all the things you can able to do here. Okay, like this you want to go through with respect to the task also. Okay, if you go through with respect to the task, here inside the task you can able to see like flat design. See here you can able to see the flat design and everything else. Like this, each and every stage we supposed to go through it. That means each and every taskbar window we want to explore. Then only it will going to be hell. It will going to be good. For that, whenever we are going to be doing any design for analyzing as well as like finding where is the things is there exactly. Okay. Now here there is the two things. One is like console window. Next thing is nothing but a script window. Here if you click one, okay, either you can able to see only one at a time. Actually, what we know like, but at the same time, if you come to this particular either console window or script window, script editor window icon, if you give the right click here, here you can able to see the three things. So this is nothing but like either you can able to see either one, either script editor or console window. Here you can able to see both. Script editor will going to be in the left side and console will window will going to be the right side. Same thing, it will going to be in opposite like right and left. So if I click here, see the both windows I can able to see at a time parallelly. This is also one of the advantage of this particular GUI mode. Okay. Once again. Okay. This is nothing but like to open the file, what are the predefined files is there. This is nothing but to save the particular thing, these two things. Okay. Here first I am going to be click here. So this is the where I can able to search my files. So if I go to the inside my script directory, there is a files. such as like power.tcl file. See, basically it will going to be show only tcl files. If you click here and if you keep it as a all, then it can show all the files. Okay, here I have only tcl files in this particular setup.tcl file, setup directory. So my tcl extension is enough for there. So now what I'm doing, like just I am double clicking on the particular run.tcl file. So if you give the double click, whatever the code is there, it will going to be replicated on this here. Next. So for example, so this is the command line which I want to execute now. Run this particular command line. If I, without selecting this particular thing, if I run, the entire script will going to be run at a time. So if I select and if I run, only that particular line will going to be run at this particular case. Okay. Next here, just I'm sourcing the just here I'm sourcing this run dot, that means setup.tcl file from the previous same thing. Now here I'm going to be the library. So what is the library name? Demo.plib. If you want to give separate name and if you want to create again, it can able to do it. Now here what is I'm doing? Just I'm analyzing the RTLs. So where is the RTLs and what are the RTLs we are going to be analyzed here? So these are the RTLs. So these RTLs we are going to be analyzing now. So these RTLs we are going to be analyzing now. Okay. To give me a second. I think I invoked the tool in the wrong place. Just give me a second, guys. Just give me a second, please. Sorry. So here is the RTLs is there. This group of RTLs which we are using now. So this is the RTLs which we are using for our current design. So one is like USB PHY.SV, USB receiver as well as the transmitter. These are the three RTLs which we are using right now. Okay. So now I can able to open my lib or else I can able to create from the beginning also. Both things we can able to do. If we save our lib like previously, we can able to open it. If not, we can able to create it. So here there is a no lib was created in the work directory because we are not saved that all the things. Okay. So again, I'm going to the scripts and again, I'm going for the run.tcl file and I'm going to create this particular lib. So at a time, I'm going to be do up to here. Okay. So we can able to move run that multiple commands at a time also. Okay. If you think like yours is error free. So if I whenever I run all this list of commands will going to be work. See, up to here the D library like dlib was created, design library was created. Next here it will going to be analyzing these RTLs. What are the RTLs it was analyzed? USB PHY is the first RTL, receiver is the second RTL, receiver transmitter is the third RTL. These are three things it was analyzed. That means it is three here. First, it is compiling the source file, it is compiling the top, then opening the two subfiles. Again, it will going to be compiling it here. Okay. And here it will going to be checked like is there any extension issues or is there any syntax issues or not, it will going to be verified. Okay. Now, what exactly this analyze command is doing? How to know that? Now I'm running some command and I'm telling like it will going to be do like this. How to know about this command? So then there is a two commands called as a man and help. You can able to do the man analyze. So man analyze. If you are going to use the tab, it is the advantage for our or a PD engineer, where you can able to get all the commands here or in the tool only, but you supposed to know which command need to use first and what is the flow. Okay, that is the case. So see here, this is nothing but a man page. This is nothing but a man page where it will going to be replicate that all the things. Okay. So initially here what it will going to be show you like what is this analyze will going to be do. Analyze will going to be specify the HDL source file and store the resulting templates into a specified library in the format of ready to specialize and elaborate for the linking. Unlike these are the sub switches is there. Here we are using the format only switch. It can able to support for system Verilog, VHDL and Verilog thing. Like this, it will going to be support for a n number of switches. Okay, and description for that each and every switch, how it will going to be work and everything. And in the below, what is the advantage is like here we are going to be get the syntax, how to use that particular command. That also here only we are going to be get it. Okay, so here see here, if you come to here, analyze format, here they are using as a VHDL like this. So if you go there here, analyze format, some name it is giving like. So like this only you can able to analyze it. That is the advantage of the PD. If you are not a coding, you doesn't have a coding, you doesn't have the capable of coding also. With the help of this, you can able to do the tickets thing easily. This is the advantage of this PD thing. So like this, you want to learn the each and every, like this, you want to learn the each and everything. Then only you can able to analyze this all the things. Then only we will get some more good knowledge. So here now I'm doing the elaborate. Same thing we want to do for the elaborate also. See here, some more new window was opened here. This is my top block. So is there any showing the any sub blocks below that? It won't show. So now I want to see the schematic. Just I'm going to give here the right click. I want to see the block diagram view or schematic view or whatever maybe. So if I click on the block diagram view, this is the way it will going to be look. USB PHP, that's it. Internally what is there? I'm not getting. I don't know. Like just it is a top block. Okay, same thing if I want to see this schematic view means this is the way the schematic view of the top block will going to be look. So internal logic we can't see. Only it will going to be show as the inputs and outputs. We in the kind of architecture format like just they know the inputs and output. They don't know the logic. Where we want to how to know the logic? That is a question. It will come to picture. Then what we want to do like along with the elaborate, we want to do the set top model. Okay, just we will close this one and we want to go and open it. Along with that, we want to do the set top model as a USB PHY. Whenever we will run this one, here we can able to see like what are the sub blocks is there inside the top block. Okay, like this. So these are the two sub blocks. This is the main sub block as a transmitter. This is the main sub block as a receiver. Inside this, these are the sub modules inside the sub blocks. Here see in each and every module how many standard cells is there, how many hierarchy standard cells is there, and every information here you are going to be get. See if you want the full name, you can able to get like this. Like complete information also you can able to we can able to fetch from here. Now, so at the first time, we can't see that whatever the things is there inside the block, right? So now I'm seeing the same schematic. Whenever if I give the double click, I can able to see here the what are the internal logic is there. What is this transmitter exactly? What is this receiver will going to be do exactly and everything. So as per our yesterday's workshop, I told you like in the digital electronics, you are going to be see this component like indicate or anything else. Somewhere you are going to be write the logic for this thing. But again in the PD we can able to visualize it. Understood? So whether whatever the gate I am visualizing there and here both are same, the both functionality will going to be same, but the properties will going to be changed. If you want to know about this particular AND gate, you can able to press on the Q. That is nothing but like select the particular component and you can press on the Q. Q is nothing but like a query window you are going to be call it as, okay? What is my query window? So if you are buying anything, you want to know about that complete thing, like if you are having insufficient knowledge on that, you will going to be raise a query, right? Like how to know that thing, how it will going to be work, the functionality and everything else. So this is a query window. Okay. So here there is a different things. If you want only labels, you can able to tell here the query text is there. Now if I click on the all, Now I'm going to be get like what is this component? What is the name of the component? What is the area of the component was occupied? What is the aspect ratio of the component? Like this, all the things we can able to see. Understood? So this all the information we'll get about this complete particular AND gate. So now with respect to the RTL engineer, AND gate is nothing but just whenever I'm passing that to any one of the input is zero, output is zero. If the both inputs is one, output is one. That's it. They are going to be focused only up to that much of level. As a PD engineer, once you enter into this particular, once you take that particular AND gate and in what level you want to analyze it, like this much of depth it will going to be there. So based on this, all the things we were going to be analyzing it. See here, here is the voltage also it was defined. What is the minimum voltage you want to give? What is the late voltage you want to give? What is the width of that particular thing? Everything it was defined. Okay, so like this, we want to analyze as a PD engineer. Okay, so this is the first case where you can able to see. Next, if you want to see only the subblock, you can select, and here also you can able to see only the subblock. Only the transmitter end you are going to be get. If you click only the transmitter, inside the transmitter, what are the things is there you are going to be get. Like this for each and every subblock also you can able to see. Okay, that is nothing but like window, hierarchy window, that things. Okay. At the same time, okay. Okay. At the same time, if you want to see this, whatever the things is there internally means also you can able to see. See here RTL models is there, objectives, like different things you can able to see from this here only. Understood? So up to here, it is clear means that's it. It is nothing but a synthesis. Okay. From here, we are going to be write. If it is a DC tool, we are going to be write the file called as a write underscore Verilog. Write underscore Verilog. Okay. Here we are going to be write some name of that particular thing, and we are going to be get this particular file name. If you want to know like what is the syntax, how to write that things and all, just a man on this command and just explore these things. If you go down, here you are going to be get that how to use the prompt also. Like that is the beauty of this PD is like they are going to be give you the prompt. See, just write Verilog, give some name. That's it. So in the worst case, if you don't know what is the command you want to use, also you can able to use the same thing. So write underscore Verilog. You can name like demo.v I want to give. So it will going to be stored in the work directory. So if I'm going for the work directory again, so there is a file called as a demo.v. If I double click on this, I can able to open this one where it is completely in the form of encrypted format. Sorry, this is in the visualization only, but zeros and one format. So this is the way your RTL code was converted into like this. This is nothing but your gate level netlist. Understood? This is nothing but your gate level netlist. So this is the netlist which we are going to be taken for the taken input as a PD. Okay. I think it was clear for everyone like what is the synthesis and how it will going to be done. What are the things will going to be happen. Okay. This is with respect to the FC tool. Save block has initial something, some name you can able to give and you can able to enter it. Okay, it will going to be saved. So now I'm going to be exit from here. So here, this is the thing. At the same time, you want to see for design compiler. Okay. Just I will show you the script, how it will going to be look. Okay. So same process, but the different scripting will going to be there. Now same thing, if I go for like CD UART protocol. So once if you also start working on this, all the things, you will also get this flow on all. Okay. First we need a practice. That's it. Like regular practice, if you have means you can also able to do like this. Okay. Whatever the things I am doing. See, until now, I'm opening the file in this separate window called as GVIM and I'm showing. Now I want to show in this console only means like in the terminal only means there is a command like cat I want to use. So this is the script which I am using for design compiler tool. This is the script, basic script which I am using. See, as usual, like with the help of this run dot setup file, I'm creating the library. Just I'm analyzing the RTLs here also. Elaborate. See, there we are using current design, but here I'm using, sorry, there we are using set of model. Here we are using current design. Like, see, minimum changes will going to be there, not maximum things. Okay. Next is nothing but like load UPF, load HDC, like echo. So these all the things, like creating the operating condition and everything, and compile ultra, like this is the command where it will going to be do the exact synthesis in this particular design compiler. Okay, same thing as usual here we are going to be get this all the reports. How that reports will going to be look if you want to see means. So here we have the reports called the report timing. Okay, so cat report timing. So this is the way the timing report will going to be look exactly. So how to analyze this timing report and what is this timing report? Why it is? If that is the question will come to a picture. So then we want to discuss these things. Okay. So what are the things we want to discuss means here? See, first thing, this is nothing but a timing report. How you are going to be tell like this is the first example for you. Timing report. Next, whether it is a full path or a partially path, full path for the complete path it will going to be. What is the delay type max? That means setup timing report it was. Is nothing but a setup timing report. If it is a hold means it will go. It is a min means it will going to be called as a hold timing report. It is a max means it will going to be called as a setup timing report. That is the two difference among the both. Okay. So setup means max. Hold means min. We're going to be called hold means min timing report. It is the one thing. Next. So what is the design? This is a design name called as some IMPL top. Next. So timing analysis we can do from the four ways I told already. One is like reg to reg, into reg. Next is nothing but reg to out, into out. Okay, these are the four possible ways. So in that, what is this timing report? Can anyone tell? That means if anyone will ask you like what is the timing report, how you are going to be explain on all the things, then you want to tell like this is the main point. So what is this thing? It was clocked by. Clock key is nothing but it consists of a sequential components. Okay. It is having for sequential component. So sequential component is nothing but the starting path is nothing but some register. Okay. Next is nothing but IMPL clock. And next is nothing but it also a clocked by some device. That means this is the name of the component. And is the name of the component. But those who are having the clock means clocked by some clock means this is the way. In between some path will be there. This is the timing report. Okay, for this path only there is a timing report which it was present here. Okay. Next thing. Next thing is nothing but, see here, you come some bit down. Here we have that two terminals mainly. There is a two things. Here if you see this particular place, arrival time and required time. Okay. Now, for example, in the real-time example, you ordered any one item. Okay. Your required time, the item supposed to come at 12 a.m. if you think. But the parcel came at 11:50 means, is there any problem for you? 11:50 a.m. No problem. At the same time, if the same item will come instead of 12, it will come by 12:30. So there is a issue with respect to this particular thing. Here also same thing. Here also the term called as a slack we are going to be called. So what is the term? Slack. So slack is nothing but like it is the difference between the arrival time and required time. Okay. For setup, for setup timing, it is nothing but required minus arrival. Okay. Always this slack supposed to be zero or positive number. It will be allowable. Whenever it will go as a negative, it is called as a violation. Is a met, it is violation. Understood? Is violation, this is called a met. Here is nothing but a required thing and arrival thing. So here what is the slack we have? Positive. That means our timing was met for the setup. Then what is this all the components and how this thing I want to analyze it? If that is the case, will come to the picture. That is the main thing. As a PD engineer, you want to analyze it. Okay. First is one thing. There is a one component called as a reg one. So that means this is the way one register one is there. The clock is coming from CLK, the name of the clock. This component is done. Okay. Next, here is some more called as a NAND gate with a 3 0 means here one NAND gate is there. Somewhere next input is coming to this. Okay, leave it. Somewhere some input is coming to this one. So it have the capable of driving the three things. Next. Next is nothing but an inverter. So for example, this thing is connected to one more inverter. So here how much delay was creating by this particular NAND gate or register? Register is giving 0.06 nanoseconds of delay. Next, the NAND gate is giving is like 0.2, 0.02. Okay. Next, the inverter is giving like 0.02, 0.02. Next is nothing but after inverter, what is there? Again the NAND gate. Again inverter, NAND, inverter, NAND, inverter. Like this, the combination is there. And here, always on chips is there. Under operation is the one thing, or and operation is the one thing. Under operation means these are where the under operation thing will going to be look. Like this, the two ones will be there. Here one OR gate will going to be present. So like this, the under operation, like under cell will going to be look. That means under this one. What are the delay it is giving like 0.02. This much of delay. OR and operation means like this, the two OR gates will going to be present. The both will going to be attached here also. This will going to be attachment. And here will be some AND gate logic. This is the way OR and logic. Okay, that is the OA we are going to be called. Okay, this is nothing but a AO. So like this, we want to analyze the timing reports and everything. Like this, we want to analyze all the reports. Okay, this is the way, this much of deeper level, we are going to be see this all the things during our course time and all. Okay, this is the basic idea what you want to get for a synthesis. Okay, I hope some synthesis was, I hope synthesis is clear for you all people. Okay. Now, just I will ask ma'am to give some like for chat access for you people. Just is there any doubts with respect to the tool with respect to synthesis and everything? You can tell me like no worries. Tool means just that netlist you want to see. Here we are not doing like full-fledgedly completely thing. Just I am showing that thing. These are where the tool will going to be look and these are where it will going to be work and everything else. You have any questions means you can ask it with respect to synthesis. First. Ma'am, is there the chart access for them? Hello, ma'am. Hello, ma'am. Are you there? Okay, fine. Okay, it's like ma'am is not active. So we'll do one thing, like just note that all the questions, okay? Again, we'll see. One, then I
Is
will.
there anything needed from my side?
Yeah, ma'am, just to give me the chat access for 5 minutes. If the synthesis tool also is done, is there any doubt with respect to that thing? Means I will help them. Next time I'm going for the PNR, that's why.
Okay, I have enabled the chart.
Yeah, only for 5 minutes it will be enabled, guys. Just asking, like
Okay.
one after one, just make sure with the clear questions what you have the doubt.
Yeah, they can
First,
ask now.
yes. Hope there is a no questions for anyone. Sir, in PD automation layout will be done right. Yes, or if you can use cadence genus, then why it is needed? See, there is a different vendors in the industry. Like few companies may use the cadence, few companies may use the synapses also. So where here we are going to be give you the both here. Now that advanced tool called as FC, that is the reason we are using this synthesis. Sorry, this fusion compiler instead of this particular thing. So where I am going to be work on this synapses vendor only. What constraints are provided to the synthesis tool? Yeah, as we mentioned, like HDC constraints, UPF we are going to be given, as well as if it required MCMM constraints, we can able to give this all the things. HDC to commands used for FC. Yes, almost all the commands are the same, but there will be a syntax differences. Once again, or there is any open source. There will be many open source, but it won't be much effective as you are taking the license from the upper vendors. So Jalen's weird owner, the ma'am will going to be handled with respect, like in the last, in the finalized thing, you can able to ask this. With respect to synthesis, if you have anything, you can tell. Okay, why we need two types of synthesis, logical and physical means. See, if you are going to be focused on only the timing and the area power optimization, then we can go through the logical synthesis, where the runtime also will going to be reduced as well as you will get good optimized design with respect to the timing and power, not with respect to the area. To use that netlist for the further, then this particular thing will going to be take more runtime during the placement and routing optimizations and all the things. If you do the physical synthesis here only, then the runtime in the PNR it will going to be reduced, as well as here only it will going to be take care of the optimization of area also. Can cat command used for PNR manufacturer report, right? So whatever the reports you can want to view in the terminal, you can able to use the cat. The floor planning has main power efficiency problem. Because in the floor planning only, we are going to be do this power analysis, like power planning we are going to be distribute. That is the way the power plan, floor planning stage only we want to analyze that particular power and everything else. Okay. Yeah. So good question. Like, what is the difference timing analysis we are going to be do with respect to front end and back end? That means with respect to front end, still there is a no clock. We don't know the exact frequency. Still here the clock is like ideal. Okay. So here with the help of HDC file, standard delay constraint. That means here we are going to be get for the average based on the average net delay only. Here we have the delays or with respect to the SDF file. So here in the PD we are going to be do with the help of the spec file. There we are going to be get the accurate answers. That means accurate timing analysis will going to be happen in the PD. But here just we are going to be ensuring that whether the timing is meeting or what. Here we only bother about the setup, not for the whole. That is the case. Fine. Okay, we'll a clock is needed in the PD file. A third clock, no sequential component will going to be work functionally. So that is the case where we want to provide the clock within this ASIC cycle. So that is the way it will comes under the PD to analyze the timing clearly. Once the PD is done, we want to analyze the timing, right? With respect to the real frequency only, we want to analyze the timing. If not, if you analyze the timing by some random frequency, if you are using the same processor, like same chip in the industry, like in the real time, it will going to be end up with a success or failure. Yeah, might be the recording will going to be. So like other softwares and all, these are basic prompt what they gave to invoke for the particular tool man. If you want, you can able to do some automation with the help of the alias command also is there. So you can able to do that also. But as of now, as the freshers also is there in our particular workshop, we want to make it everything in a simple and understandable way. That is the object. Okay. Yeah. Okay, ma'am. Like now I'm jumping to the PD. You can stop that access also. So rest of the people who have the questions, just make a note of the questions and finalize the thing. We can able to see. Okay. Thank you guys. Next, before starting the PD, first of all, we want to know that inputs for the physical design. So without knowing that inputs for the physical design, there is a no use. So I told you to show, I will show these things, right? Right. I will show that lib file and everything. Then you will get some more clarity before going to that inputs itself. Okay. So this is the technology file. This is the way the technology file exactly will going to be look. Okay. So all the things like authorize everything. First thing is number C, technology. What is the name? Sayed 32. What is the day? Like when this technology file introduced and everything else. Like what is the units for timing precision? Okay, what is the units for length precision? Okay, what is the units for voltage name? And what is the voltage? It will going to be exact. Like everything it was predefined in the technology file. Okay, technology file consists of this all the predefined units and everything. Along with this color information, what the metal layer is supposed to be look and appear in the particular design. And next is nothing but this thing. So if you go down here, you can able to see like this is the way the pattern matching will going to be there. With respect to this pattern, there is a few more things I told like parasitics near TL min and max files will be there where these two things will going to be mapped. And this is the way it will going to be look. So this is the where it will going to be look for the same thing. See here you can able to see layer means via. So what is the specifications of this particular via and everything else. See here only you can able to get like what is the minimum pitch, what is the minimum width of the metal layer. For example, if you are going to be take with the M6 metal layer, see what is the layer number, mask name, how it will going to be visible as it is a blinking or like perfect color, or what is the line step, it is nothing but a solid, pattern is nothing but impeded, default width is like default pitch is nothing but 0.608, width is nothing but 0.056, minimum width and minimum spacing, maximum width and same net minimum spacing. Like this, all the things will going to be present in this technology file, which was given by the foundry. Based on these things only, our PD, where the tool will going to be fetch and it will going to be do this all the routing and everything else. Okay. So these are things will going to be present in this technology file. So next is nothing but TLU min and max files I told, right? So this is nothing but a min file and this is nothing but a max file here. So the to interconnect this technology file, this in technology file with this min and max file, it is using that is nothing but ITF. ITF here full form is like interconnect technology file. If you see the minimum, that one minimum value it can be take up to here. See the minimum value of this particular thing. See, for example, conductor like M9 metal layer is there. What is the thickness of the metal layer? Width minimum width is there. Spacing minimum. Like this, all the information will going to be present with respect to metal layer. Here it was completely encrypted format, which we can't understand like. Okay, if you want to see this one, there is a one more tool called as a RVE, result viewing environment. In the PV, it will going to become. So with the help of that tool, if you give it as input, then it will give in an understandable way. So this kind of things will going to be present here. Understood? Now what are the files we saw? We gone through about this technology file and this thing. Now one more thing is nothing but lib file. So where it completely consists of in the completely in the form of the encrypted only, where we can't see that all the things. So where this lib file consists of the complete timing, like complete air, sorry, timing as well as the power information. Okay. So this with respect to wires and everything. So here see complete information like this. It will going to be look. That's the reason we are going to be learn this what is information present in the libs and technology file and mean and max as a overall thing, which we cannot visualize it. But with the help of this encrypted only, it will going to be happening. Okay. Next. So we know that what is the input, like inputs required for the physical design here. Okay. The inputs required for the physical design is like before starting the physical design for we require several inputs such as from the three teams we want to get a inputs. First team is nothing but a front end team. Okay. Next is nothing but a library team. That is nothing but a foundry people, what we are going to be called. And next is nothing but a technology team, where you are going to be get these constraints and everything else. So inside that files, what are the different information will going to be present? Means one is like design connectivity, timing constraint through the SBC, like this is from RTL or gate level netlist. RTL or gate level netlist. This is nothing but a timing. This is nothing but a self physical information. This is nothing but self physical information. This is nothing but a technology information. It is RC and power intent. Like this, the different inputs will be there. Based on that, all the things it will going to be work. So what are the input files means like one is like netlist, SDC, lib. See netlist means it consists of all the standard cell connectivity. SDC means already we saw the timing constraint. Lib means timing and power area of all the standard cells. Left it consists of complete the physical information of a shell. Like def is nothing but once we done with one stage, so for the next like in the industry all the stages is not doing by a single person where the certain teams will going to be do the certain stages at the time whatever the stage once the floor plan is done whenever we are going to be submitting for the placement team we are going to be extract the complete information of the floor plan in the form of the def design exchange format we are going to be called def is nothing but library exchange format def is nothing but a design exchange format. Next, this is nothing but a technology file. What we saw right now, this is nothing but a RC, TL min and max file. This is nothing but a power intent. Yesterday I told you like this is your core area means either the entire core will supposed to work with a single voltage or more than one voltage. So this power intent will going to be decided by this thing. Why this UPF is important? Right? Nowadays we are doing that low power designs. So where power is the more critical. That's the reason. Okay. Okay, what exactly the information consists of and everything here we'll see some clearly. So once it is done, just we'll see that what are the things will going to be there in the PD, and just we are going to be jump into the tool and we'll see like practically what is there, what is the content and everything else. Okay. So first it is nothing but a netlist. The netlist is the output of the Synopsys. That means netlist is the output of the synthesis that contains the standard cell and their connectivity information. Like this, already we saw the netlist. It consists of the standard cell and its instant names as well as the connectivity information. From where we are going to be get this netlist? From the synthesis tool. Okay. With respect to PD engineer, why the netlist is required means what shell to be placed during the placement stage and how the shell is supposed to be connected during the routing stage. So only these two things we are going to be get from the netlist only. That is the main reason where we want to use a netlist. Without that, we can't do the placement as well as the routing. So rest of these stages we can do means yeah, we can able to do it. That means from placement to routing we can't do without netlist. Floor plan we can able to do it. Okay, just if you know some area, you can able to do this floor plan and all. But without knowing the without having this particular gate level netlist, we can't do the placement to the routing stage. Okay. Next is nothing but like SDC constraints. So that it consists of the timing information. So maybe this requirements this is design means to timing analysis to perform timing analysis it will require to verify the timing analysis. It like clock definition, input delay as well as output delay, false path and multi-cycle path. So these are where this one already we saw. Okay, this is the main thing and most question in the interview is right difference between the left and left. So we're going to be struggle there during the interviews. The information are standard cell. This is a standard cell if you think. Okay, this is a standard cell if you think. It consists of cell width. That means this is a set row. So this is where it's placing here. What is this width? Physical information. Next, what height? The chip also it have input means what is the location exactly. Next, is there any routing blockages for this particular standard cell? And what is the metal information? So which metal the particular pin was built? That means this pin was made up of using which metal layer. So like this kind of physical information will going to be present in this particular left file. Okay. Next, this left file doesn't have any timing and power information. Why? Because of timing and power will going to be consist of the lib file of a same standard cell. Next is nothing but like why PD needed means like during the floor planning, placement and routing, with the help of this physical information only, we are going to be decide the chip area and size. Okay. So based on this particular standard cell area only, the placement will going to be happen whether that is like conjectured free or it was conjectured, we are going to be deciding. So for example, this is your core area, you can place 100 standard cells if you think. Instead of 100, if I place as a 2, if I try to place a 200 means it will going to be end up with a conjecture. If I place 50, it is like underutilization. Like based on that, you want to place it properly. For that thing, for this kind of scenarios, the particular left file will going to be helpful during this placement stage. And routing also. Like on which metal layer the pins are connected. Why? Because of if the two metal layers are same, to interconnect between the two metal layers, no via is required. Okay, if this is a M2 metal layer, this is a M3 metal layer, if you think this is M3, so here we require a via to connect between the two dissimilar metal layers. Okay, so to know to do this all the cases, so we require this particular left information of the standard cells. Okay, next is nothing but a lib. Already we saw it consists of these things like cell delay, setup time, hold time, power data, and as well as timing arc. This is a new term which you are going to be here called as a timing arc. If this is the gate, this is nothing but a timing arc you are going to be called. This is nothing but one arc from here to here. How that how much time it will going to be take? This time it will going to be take like from here to here and from here to here. These are nothing but timing arc. Here it will be done by using the PBA and GBA analysis. Okay, especially this will going to be helpful for PBA, path-based analysis. Path-based analysis, where it will be more accurate than this GBA, where this GBA will going to be give the overall delay, like average delay, not the accurate. PBA, it will going to be give you the accurate delay for the of a particular path, whether it may be reg to reg or into reg or whatever may be. Okay. Next, so the main difference between this left one lib, one should want to remember like this is the thing. So left consists of physical, cell dimensions, pin location used for placement and routing purpose. This is for timing, cell delay, setup and hold timing used for STA, timing analysis, as well as a power analysis also you can able to take. It is for power analysis also we can able to use it. Next is nothing but a def file. Okay, that is nothing but a design exchange format. Okay, in this design exchange format, it consists of the both physical plus logical information, whatever the things we did in the particular stage. Okay. So, for example, it consists of like we can able to extract the floor plan depth, placement depth, as well as the routing depth, whatever may be. That means this depth file will going to be generated during the PD stage only. Mainly, we are going to be generate this def file from the placement as well as the routing. Okay. Next, this def file is going to be used for data transferring purpose between this different PD tools. So this is about the def file, where it consists of the physical layout information of the design. So, on to tell. See, whenever you are attending any interviews or anything else, first thing you want to know about that, what are the inputs and what information it exactly consists of, on which stage, and why we want to give that input to the PD on the particular stage. That is the main objective of these inputs. Okay. Next is nothing but a technology file. So already we saw like technology file consists of metal layer as well as the via and design rules and properties something. So it consists of like this different metal layers and via information like minimum pitch, minimum width, minimum spacing, maximum. See, for example, it is a M2 metal layer. It will going to be look like this in your design means. If again M3 also will going to be look like this only means, whether you can able to differentiate the both, no, it is difficulty. That is the way the different patterns will going to be introduced in the technology file like this. Something will going to be dotted. Okay, something will going to be like crisscross connections will going to be look like these are different metal layers will going to be look with the different patterns. Mainly this technology file is helpful during the routing and VRC. Okay. Next is nothing but a technology file. It is following the manufacturing rules as well as the process node. Like what is a nanometer? It is a 5 nanometer, 4 nanometer, 3 nanometer. Okay. Then is nothing but a TLU min and max file. It consists of the complete metal layer RC information. So this is the metal layer. Per unit length, what is the resistance and what is the capacitance? So as we know, like in the series, always the resistance will going to be add like as a R1, R2 like this. Like that, like per unit length. If here I am giving this much of this is the distance, what is my resistance? From here to here, what is my resistance? If I'm giving input at here, what is the output I'm going to be get? So how much it was drop, like voltage drop is there. Based on this per unit length resistance only, we are going to be calculating this all the things. Okay. Next is nothing but why it is needed means during the routing as well as it will going to be decide the timing effect. Okay. And one more thing, what we want to learn, like if the higher metal layer, like in the PD, there is like M1 to M9 metal layer, the resistivity of the M1 is more, and the resistivity of the here it is more. The resistivity is less. That is the reason for the power planning, and we are going to be use the highest metal layers instead of the lowest metal layer. Why? Because of we want to distribute the power to the entire design. So if the resistivity is more means whatever the power we are giving from the external world, it will going to be restrict there only. If we use this higher metal layers, then there is a maximum power can be distributed to our chip. So mainly this CLO min and max file is going to be used for RC extraction and delay calculation during the STA, and it consists of the complete wire delay information in this particular file. So these are the few important and mandatory files which we want to give for the PD. Without these files, we can't perform the any stage in the PD. Like okay. Next, this is nothing but a CPU or CPF or UPF you are going to be called. So now one person called asked like in the why can't we use the cadence? The same design you are going to be implementing by using the cadence, you want to use the UPF file in the form of CPF, common power format. If you are using the Synopsys vendor, then you're supposed to use it as a UPF, unified power format. That means it was predefined. Further, this UPF and CPF is classified into three types. One is nothing but like golden. Okay, next is nothing but a supplementary. Next thing is nothing but incomplete. Okay, in incomplete is nothing but just we are writing some basic UPF code and UPF script, and we are going to be proceeding with the stage which supposed to be changed in the further stages. Supplementary means, so if I am taking the UPF as an input for my synthesis, okay, I can extract the UPF from the synthesis. From synthesis, I can able to extract the UPF. Okay, whatever the extracted UPF is there, right? Extracted UPF, this UPF is called as a supplementary UPF. Okay, this is nothing but a golden UPF, which was fixed and predefined and everything is perfect for your design. No need to change in the any stages. It is coming from the power team. So like this, the three things, three different types will going to be present. As a PD engineer, initially we are going to be use the incomplete UPF or then for the PD, like from the synthesis, we will get some supplementary UPF, and we are going to be used initially these two things. Once the power plan is done, during the power plan stage, we are going to get this golden UPF. For initial four plan, we can able to proceed with these two things also. If it is golden is there, it will be good. If not, we can able to move with this also. Like, and here it stands for unified power format, and it describes the power intent, like how the power supposed to be distributed to my design. That is the case. Like this is the thing already we discussed. Like this is one voltage, or entire thing is supposed to be work with the same voltage, or what it will going to be decided. Here, this is not. These are the few things will be there. What we are going to be writing through this, providing to this UPF. One is like power domain. So this is nothing but a P1, which will going to work with the 0.1 volts. So this is the domain 2, P2. It will going to work with the 0.2. Whatever the standard cells have the threshold voltage of 0.2, they will come and place at this thing. Here, 0.1. So it is like 0.3. Like this, the power domains will going to be. And power switches. So the power switches, with the help of these power switches, we can able to control the power consumption, like power dissipation. Next, isolation and retention cell. So isolation cell is nothing but like when, for example, in this shape, you have the two blocks. Okay, where from the output of this particular block is like always zero. So at that time, to generate that zero output, no need to, if you are going to be if you are going to provide the power, clock, and everything to this block, means the power consumption will going to be increased. At that time, you are going to be use the shell called isolation shell here. You are going to be placing here. That is nothing but a zero with a clamping zero. So which will going to be drive continuous zero. If it is in off also, it will going to be drive. If it is in the off state, there is a no power consumption will going to be occur. So like this. Retention shell means if any sudden power shortage or power cut will going to be happen, means like whatever the previous data is there, the data will going to be retained. That is the purpose of using this retention shells. Mainly, we are going to be used as a memory element. We are going to be called. Okay. Mainly, this all the things will going to be helpful for the low power designs, and this is applications. So, as a low power is the advanced technology is nothing but in the advanced innovation they are using. They are looking for the low power devices. That is when we want to use this UPF as a more efficiently for power saving techniques. So it consists of the power management information of the design. Okay. Okay. Before starting the any stage, what are the inputs you are getting? Like now I told you like we are going to be create the library. So before creating the library itself, what are the inputs we are taken? We taken this .pf and .ndm. Okay, .ndm. This is the two things we taken. So we want to verify these two things also. How to verify it means that is called as a sanity checks we are going to be do checking that particular thing. So there will be two types of sanity checks before and after the stage we are going to be start. So why we want to do the before as well as after means before starting means so whatever the inputs we are taking for this particular stage, whether the inputs are proper. See if inputs itself there is any errors, is there any mismatches, is there like not complete information in the input file, then there is a no use of doing that particular stage. If you do also the particular stage will going to be end up with the violations only. That is the way we want to ensure like from the previous stage, what are the input we are getting as well as what are the inputs we are taking for the stage. It doesn't, it's supposed to be clean. It's not supposed to consist of any violations and everything else. Okay. So first here we want to do the library checkup, library checks. So here we are going to be checking missing the cell information. So here in this library, we saw like left and lib. Okay. In the lib for one and get particular power information is not there means it will going to be impact for the power analysis. Timing information is not there means timing analysis. Like this, we want to make sure that there is a no missing information for the particular shells. It has like complete information, like any pin information or duplicate cells, like this kind of things. And design. So whatever the design we are taking from the previous stage, we want to check that. Is there any floating pins or is there any tri-state drivers or nets with the multiple drivers or combinational loops or empty module? These are all the things. Empty module is nothing but like, so inside this thing, this much of place it was occupied by empty module, but there is a no logic inside it. Then what is the use? What is the use of this particular using this particular empty modules? Okay, so we want to make sure this all the things not supposed to be present. Okay, what are the inputs we are taking from the previous one? Then we want to verify the constraint check. So this constraint check will comes under this, what are the input files you are giving for the particular stage. This is we are going to be taken from the foundry. This is we are going to be taken from the previous stage, and this is we are providing for the particular stage. This is the case. Okay. This is a basic check we want to do. So first thing, this is nothing but a partitioning, which as a fresher, it is not required. Like where the experiencer candidate, like in the position of senior or director level, they are going to be do this partitioning and everything. That means in this partitioning, what it will going to be happen, like whether we are working with the top block or sub block, it will going to be taken. Whether we are going to be working with the top block or sub block, based on this thing, the partitioning will going to be decided. That means, so whenever we are constructing the house, we are going to be decide like this is the some room like R1 is supposed to be here, R2 will supposed to be here. Like this, here we are really defining the positions of the blocks. So this entire thing is called as a top block. Okay, this entire thing is a top block. These are the sub blocks, where actually a separate teams will going to be handle these blocks. As a single person can't do the entire the block. As separately we are going to be doing that each and every stage, and we are going to be integrating this all the things. Okay. So while separating this all the things, then with in the stage of the partitioning we are going to be do. Here we are going to be use the two techniques. One is like flat as well as the hierarchy. Flat is nothing but like only the one module, like only the top module is there. There is a no subblocks inside this. So that is called as a flat design. There is a no subblocks inside the top block. While coming to the hierarchy, so this is nothing but the top one. So top again it consists of like sub one and sub two. Again it consists of like one and two. Okay, S11 and S12. So that means first we want to do this subblock. Next we want to perform the entire process for this one. Then we want to integrate this two with this one. Like this separately, these two things we want to do. Then we want to do the top integration. So this kind of all the partitioning and everything will going to be done before the floor plan itself. So here only they will going to be decided. See, here the shape of this particular chip is nothing but rectilinear. It is not like a square. It is nothing but a rectangular. It is like something different shape. So this shape is deciding during in the partitioning time only. Based on that and based on the standard cell area, we want to design the same shape here. Okay, that is the use of this partitioning. So now the floor plan will coming into picture. Once the floor plan is done, just we'll jump into the floor plan and we'll complete the floor plan. Okay, like stage by stage we'll go practically as well as the theoretical. Floor planning is the first and most important stage of the physical design. Why? Because of, see, for example, in the floor plan, this is the where we are going to be deciding the core area and die area. If you are not define the proper core area and die area, it will going to be impact for the each and every stage in the further with respect to the different formats. Like if the core area is not enough, it will going to be end with the conjunction issue. Okay, if the core area is more, then the shells will going to be placed like more distance from each other. Like this, one shell is here means instead of placing here, it will go and place here. It will going to be end up with the timing violation. Okay, with respect to the routing means it will going to be take the more metal wire. Okay, like the manufacturing cost also will going to be increased. Like this, it will going to be impact with respect to the many things. If I want to distribute the power from here to here, the metal resistance will going to be more. Because of that, IR drop also will going to be will going to be occur. Because of that, the power issues also will going to be facing after the design. That is the reason like we are telling floor plan is a critical stage, which will going to be directly impact as well as affect the further stages with respect to the timing, conjunction, power, routing, and chip area. This is the thing. And while coming to the PD flow, this is the flow which already we discussed, like from netlist we are taking and some library information and technological team like constraint information we are taking and we are doing this PD flow like. So this is the main objective of the floor planning, like to make sure the minimum area, minimize the timing and reduce the wire length and make sure routing easier and IR drop. So why this IR drop and with respect to the what format we want to think like. So based on the whatever the area we are going to be taking for core and die, based on that one it will going to be decided. Okay, if my power ring is here, and my power mesh is here. Like the whatever the connection is taking from here to here, it also consists of the more wire length. We want to make sure this offset also. That means we want to try to reduce the wire length. That means here this is your die area. This much supposed to be the offset. Then the resistance will going to be less. Okay. So like this, we want to make sure. And the inputs, what are the inputs we are going to be taking for the floor plan is nothing but like netlist, HDC, and lib. And what are the things we are going to be doing in this particular four plan stage? Like there is a flow actually, complete four plan stage. First, we are going to be binding this particular netlist with the physical libraries such as lib or technology file, whatever maybe you are going to be called. So based on the netlist standard cell area, we are going to be calculate the core area and we are going to be creating the core area. Next, once the core area was created, that means once like this, the die and core area was created, then here we are going to be place the IO pin placement. That means here we are going to be place the IO pins first. Okay, once the IO pins is done, then we can able to place the pad rings. Here, pad rings also we can able to place. So like this, around this thing. Next, place the macros and standard cells. That means if this is your core area, okay, so here you have the pin connections. So there will be a one more thing called as a macro placement will going to be depend on fly line analysis. We are going to be called fly line analysis. Okay. So in this fly line analysis, what we are going to be give like there will be three priorities. First priority from macro to IOs. Next is like macro to macro. Next is nothing but like macro to standard cell. So that means if any macro have the more connections with these pins, then that macro will going to be placed near to this one. Okay. If this macro have connections with another macro means then that will going to be placed near to this one. So like this, based on the priority, we are going to be placing this all the things. And we can able to create a rings for around the macros also, as well as the power we are going to be distribute and everything. Okay. And here we are going to be checking like whether the four plan stage is like proper or not. Here, normally we are going to be called as a four plan and power planning, right? But the combination of four plan and power plan is going to be called as a chip planning. Okay. Chip planning with respect to this, both the combination of four plan plus power plan, we are going to be called. So the types of four plan techniques is like averted, non-averted, and mix of both. Averted is nothing but the channel between the channel less placement of the blocks. That means whenever we are going to be place the macros or any predefined modules in the core area, if you are maintaining any space, that means if you are not maintaining any space, if you are attaching the both the blocks is means that is called as a aberted. That means when in what scenario we can use the aberted technique. If this is one block, okay, this is the two predefined blocks which I have. So this side there is a no pins. If you think this side there is a no pins, this side also there is a no pins. Then I can able to abort these two things like this. Okay, so like this I can able to abort the two things. If I have the four sides of the pins means, then I want to use the non-aborted technique where I want to leave the minimum spacing between the both. That is nothing but a channel length we are going to be called. So what is the distance between from this model to this model? Like how much I want to leave means sum of the pins of this plus these pins into pitch of that highest metal layer divided by overall metal layers. So what is the numerical you are going to be get minimum that much of space you want to leave. In general, you are going to be tell like a pair of VDD and VSS metal layers supposed to be allowed the space within the space between the two blocks. That means within this space, a pair of VDD and VSS, one VDD and VSS metal layer supposed to be allowed. So, and in that scenarios, we are going to be use the non-aborted floor plan. So mix of the both means this is nothing but a mix of the both. Few were aborted, few are not aborted, like this. And main terminologies is nothing but utilization. Utilization is nothing but like the area of the core that is used by the standard cell placement and macro placement. That is, this is your core area. Like this, the site rows will going to be look. Okay, within this site rows, this much of area will going to be used by the standard cell. So here the core utilization will going to become like this area plus this area plus this area. This whatever the rest of the area it is not comes under the core utilization. Okay. So these things. So minimum it can be allowable like 60 to 70%. Okay. Or 70 to 80% for the complex designs. Next, manufacturing grid we are supposed to know. So in this manufacturing grid means the smallest geometry that semiconductor foundry can process or smallest revolution of the your technology process. That means it is nothing but like geometrical representation where the standard cells will going to be placed with respect to the with respect to the technology node we are going to be called. So these are where the floor plan steps will going to be look. This is the out like top appearance of the core area and die area. So this is nothing but offset and everything. Here for macro placement, we are using flyline analysis here. This is the case. And next is nothing but like based on the here we are doing flyline analysis to place and macro placements is required as well as we want to consider that all the whatever the connections and everything is there, otherwise it will going to be end up with the congestion issue. And blockages and management, like once if you place a macro, you want to create a blockage around the macro like this. Few cases it will going to be called as a halo also. Halo and keyboard margin we are going to be called. We want to know the difference we were supposed to know the difference between halo, keyboard margin and blockage also. Okay. So these are basic terms. One is like utilization we are going to be called. That means the sum of the total standard cell area plus macro area divided by total core area into 100. Then you are going to be get the utilization as 0.7 or 0.6 like this. This is nothing but a 60%, this is nothing but a 70% like that. Aspect ratio. This is the main thing which will going to be deciding like which kind of routing resource will going to be more. If the aspect ratio is 1, height by width equals to 1 means it will going to be look like a square shape. If height is 2 and width is 1, so then sir, width is 2 and height is 1. Then what will happen? It will going to be look like as a rectangular shape. So like this, the shapes will going to be vary. Okay. So this is the importance of the aspect ratio, like routing resource available in this for the design as well as it will going to be decide the how the standard cells will going to be placed in one side row and how many standard cells will going to be placed also. It will going to be define. It can able to define that based on the frequency, what will be the timing analysis as well as what will be the timing violations also in the further stages. It will help for the doctor synthesis and IO padding and everything else. Okay, this all the things will come under. So this is under like low utilization where there is any many empty spaces between the standard cells. It is nothing but like high standard utilization. Here the utilization among like 60 to 70%. It is like 70 to 80% will be there. Okay. So these are where you are supposed to look this height by width and everything else. So these are where the macros supposed to be placed like. So this is the gap between these two things is there, right? So this is called as a channel. This is called as a channel here. And these are where you want to maintain the minimum spacing among them. Okay. This is better floor plan. These are like problematic floor plan. Why? Because of one macro is here, another macro is here. Some cytos is going here. So whenever the connection is happening, some other standard cells also will going to be placed in between here and all, which will going to be end up with the violations as well as the congestion and everything. So but never the macros will going to be supposed to place like this. Always the macro placement supposed to be look like this only. If the two things have connections, it want to look like this. If you are placing like this, and the connections will going to be look like this, and it won't seems good. It will going to be called as a crisscross connections. We are going to be called, which will going to be impact on timing, especially timing and congestion related issues we are going to be facing. So this is the where we want to verify like floor plan quality, like number of there is supposed to be no shots in the input output ports, and IO ports should be placed properly with respect to routing grid, and you're supposed to make sure like there is no overlapping among the macros and everything. Macro file analysis you want to follow properly. You want to create a channel. You want to maintain a channel spacing, or you want to create a halo or keyboard margin also if it requires. And this all the few necessary things we want to make sure to tell as it is a good floor plan. And these are the outputs we are going to be get from the floor planning stage. IO port placement and the cell row creation information, macro placement information, core boundary and pin position, everything. Okay, now we'll jump into the tool directly, and then we will come to the power planning. Second. Just to continue this power planning, and then we'll once we are going to be jump into the tool. Okay. So while coming to the power plan, here we are going to be do the power distribution. So that means, so those are called as the rings, rails, and everything here. So here it was predefined. So these are called as the rings. You are going to be called. Those are called as the pads. IO pads we are going to be called. Okay. So initially the power will going to be get to these pads from pad to the ring. From see, this is nothing but a mesh. From the ring, the power will going to be get to the mesh. Okay. From the mesh to the rails, this red color thing is nothing but a rails where the standard cells will go and connect to this particular rails directly. Okay. These are where the power distribution will going to be happen here. The main important things and terminologies for the power planning is nothing but like EM and IR drop. Next is nothing but a power routing also is a predefined thing. So here inside this thing, so these are called as the rings. Like mainly what are the things we want to create in the power planning is like power ring, straps, mesh and grid. Power grid we are going to be called. So the combination of these mesh, straps and rails, everything is called as a power grid we are going to be called here. Okay. So here, if the metal layer is like M9 and it is like M8, so here to connect between these two metal layers, we are going to be using a thing called as a via. Okay, that is nothing but a via insertion we are going to be called. And what are the technical terms and required for the power planning is like, so first of all, total dynamic power information we require. So get from the compiler, like we are going to be do the power analysis. Based on that, we are going to be get power. Okay. So from this power information only, we are going to be decide like how many straps and what is the minimum width of this strap we want to maintain. What is the maximum width of this strap we want to maintain. That all the things will going to be decided here. Next, technology file will be provided for the current density. Like what is the amount of current we are going to be distribute through this. Based on that only, it will going to be decided. Okay. Left. That means with the help of the left file, we are going to be get the metal layer width and everything else. From the technology file, as well as the standard cell information, we are going to be get this 4 voltage information and everything. Okay. Based on these things, it will going to be decided. Okay, this is the way the rings and particular straps, rails and everything will going to be do. Okay, give me a second. Just I will check with this one tool supposed to work. Okay, so directly I will open and I will show you this all the things. So here directly we'll see from ICC to directly. Shall- so here- so because as timing is getting closer, just whatever the blocks is there, and I will give you the overview of this tool only. Okay, first I will give you the overview of the tool, then we'll jump into the theory. Okay, finally, like I'm planning to cover this everything by the tool first. Then finally I will show that what are the things we supposed to be expertized in the PDF. Okay, same thing how the FC tool will going to be look here also it will also going to look the same. But what is the difference among them is like few commands as well as a few syntaxes will going to be vary. Apart from that, nothing is there. Okay. So why? Because of here it was very clear for you, but now in the current industry they are using this FC. Okay. So this is the where first whenever we will run the this is your top block. Like once your routing and everything is done, this is the where it will going to be look. So within this, you want to know like now what we are doing for planning we are going to be do. So first enable this all the things and disable it. So there is any floor plan, nothing is there. You want to see the core area. So this is nothing but your die area. What is die area here? This is nothing but your die area. You are going to be call it as die area. Okay. Next, this is called as a core area. Next, the distance between core to die is there, right? This is called as a offset. What it is going to be called? It is called as a offset. Is the distance between this thing. So now you want to calculate these two things means how you are going to be calculate. So there is a here we have the thing called as a ruler scale. Okay, here there is a two scales with respect to timing. This with respect to ruler. We supposed to take the ruler scale. If you click on here and if you calculate like from what is the offset? Offset is nothing but 5. Okay. So what is the core area now? Core area is nothing but height into width, right? So height, what is the height? It consists of 36.784. So you want to calculate the width. This is nothing but your core area, like width. You want to calculate the die like this, you can able to calculate and you can able to do. Okay. So this is the way you can able to do this, calculate this timing and like floor planning and everything. Now you want to create your own floor plan, like not with the help of the command. I want to do from the tool. Then how you are going to be do means go to the task. Here is the option called as a design planning, where everything here from here only you can able to do. Okay. Next, here is the thing called as a floor plan preparation. If you double click on it, this is the way you can able to see. See here, you can able to learn this all the things very clearly also, if it requires for you. Now, initialize the floor plan. That means I am planning to start the floor plan. So now I am giving here as a code. Utilization is 70%. I am telling. Here I am putting the shapes. Like see here, there will be two boundaries, core boundary as well as the die boundary. Is the template is the customized thing. Template means what are the predefined things is there in the EDA tool, we can able to use it. If the customizer means what are the shape you required, you can able to draw it. That is nothing but a customized thing based on the partitioning. We are going through the customized thing only. Okay. Next. So this is nothing but a core area. If your design is like pad limited, there is a two types of floor plan also is there. One is like pad limited, next thing is nothing but a core limited. That means number of pins, input IO pins is less means, and the standard cells are more means, that is called as a core limited. If the number of pins is more, IO pins is more, and the standard cells is less, that is called as a pad limited design. So here ours is like core limited. That is the way. Just here I am giving the core utilization. Okay. Here I want to give the side ratio. See here, if for the rectangle I can able to give the side ratio as a 2 2. For example, if I think, then here I am giving the offset. What is the offset? It's supposed to be look. So one side I will give 2, one side I will give you 10. For example, to show the differentiation. So if you preview here, this is the where it will going to be look. Okay. And here you want to tell you like uniformity or keep die boundary. Disable this, and if I enable here has a 10, if I preview my design, this is the where my design will going to be look. If for example, now I'm increasing the size of this one. Okay. If I preview here, this is the shape. Okay. If that is not required, now I need the L shape. See here, the number of sides will going to be increased. So 4 and 3. So here now, this is the shape of my L. If I vary these things, then instead of like I will give 2. So now you will get some proper L shape. So this is nothing but a L shape. At the same time, if you need like T shape, okay, where you want to give for everything else here. 2 and 2 if I give, if I preview, so these are where my T shape will come to the picture. Okay. If I reduce this 3 and if I give here 2 only, then you can able to see this is my T shape. So these are nothing but like templates. What are the things it will be present? This is nothing but orientation. See, west means now it will going to be look like this. Okay, south means it will going to be look like this. So this all the things we can able to do it from here only. Okay. Now, what is the command? No, now I'm not interested to do with this GUI mode. I want to write the command. We want to write the command like this. Okay. Initialize floor plan, switch shape T, orientation, east, west, or north, south, and keep boundary, side ratios. What is the side ratio? So what is the core offset? Like this, you can able to give. So this is the way. This is nothing but like template format. If I want to do from the core, I want to select here. Okay, keep die boundary. Keep boundary for the core shape. So offset I'm giving using as a 10, right? So just here I'm minimizing it. Second. Okay. So here I'm selecting this one. Next, I want to select here as a placement side grid. I want to select this. Okay. Now I want to minimize this one. If I want whatever the shape I require, I can able to draw here. Sure. See. See, whatever the shape I require, I can able to draw it. So once this is done, again we are going for this thing. Okay. So now you want to select the die area. Now here die boundary followed by the core area. So same thing you are going to be keep and you are going to be executing. Here it will be like very small. Whatever the area I drawn, it is like very small. Like this, you can able to do the customized thing also. For that thing, here is the coordinates. So like this is the two ways of doing the floor planning. Whether you can able to do by through the command or you can able to do by the template or customization. This is the two ways you can able to do this floor plan. Okay. Once this is done, how to decide this core area? So whenever you run the command called as a report design, report design. So here you are going to be get the total area from here. Okay. Total leaf cell area and everything like total area here you are going to be get. You want to take this area and you want to give as a standard cell utilization, like core utilization you want to give. Like before we saw the formula, right? Standard cell area plus macro area divided by total utilization. So like this we want to give and we want to get the, we will going to be get certain numerical. For that we want to write the command or we can able to draw the customizer thing. If you want to know the utilization, what is the utilization of your floor plan means report utilization, you want to use the command. So your utilization is like 73%. It is around 73%. If you want to reduce the utilization, increase the area. If you want to increase the utilization, reduce the core area. These are two ways where the floor planning you can able to do. So macro file analysis, if you want to do the macro file analysis, this is the where the macro file analysis you can able to give like data file lines. Okay, like this you are supposed to do the data file lines. Here the certain options will going to be visible for you people. Second, I will show you this by opening that next block. So here I have these things, right? So these are nothing but my input output pins. Okay, how I place this input output pins means there is a separate script for that. So this is the script which I used to create this floor plan. So initially, as usual, like we are creating the library and everything. Okay, next once the library and everything was created, then I used the command called as initialize the floor plan and boundary with some certain coordinates. I gave the offset as a 5. Here, see, before starting the any stage, I told you like you want to do certain the pre-sanity checks. Okay, this is the pre-sanity checks which you want to do, like check timing. Just give me a second, guys. Okay, sorry, guys. So this is the few sanity checks which we want to do before starting the forefront itself. First thing is nothing but a check timing. That means, see a report timing command we saw, but never we saw the check timing. So if you run the command called as a check timing, here you are going to be get like, is there any errors with respect to the timing analysis if I want to do the timing analysis for this particular design in the future. So I am taking the input as a netlist, right? So is there any mismatches in the netlist? Is there means it will going to be show. Next, design mismatch, report design all. That means give me the complete design information for me. Like how many standard cells is there, how many wires is there, like everything complete information with respect to the metal layers, boundary shells and everything else, it will going to be give the complete information. See here you can able to see is there any hard blockage, soft blockage or hard macro, everything it will going to be give here. Next, with the help of this command, so especially we want to use this command, is there any mismatches? Like you declared RTL name in the RTL has some name, it was replicated in a different name in the netlist. It will go there will be going to be issue, right? So to avoid that all the things we want to verify through this command called as a report design mismatch. So it's supposed to become one, it will come as one means there is a no mismatches. Is there any mismatches means then again we want to perform the synthesis properly. Then again we want to extract the netlist and we want to use this netlist. Next here we are using like initialize floor plan and report utilization already we showed. So this is nothing but a UPF file. Okay. So exactly the UPF file will going to be look like this. So the UPF file will going to be look like this. It is for the single domain. Okay. It consists of supply nets and supply net. It is nothing but supply nets we are creating for the VDD and VSS. Here I am giving the supply net for one name for the particular net called as a high voltage. With the what is the net? What is the voltage? It will going to be it will going to be carry VDD voltage has a power and function and ground has a VSS. Okay. Here I am creating some name to the domain name here I am creating. What is the primary voltage it will going to be going for the particular domain? Here I am specifying with this whatever the name here I created. Okay. Then I am giving the directions whether the voltage will go as an input or we are going to be get as an output from the block or what. This is the logic. Whenever my input voltage is 0.95 and the VDD is 0.95 and VSS is nothing but like 0.0, then the particular chip will go supposed to be work. If not, it's not supposed to be work. That is the logic behind that. So here you can able to see your UPF. What are the UPF there I showed you. Same thing here you can able to see here. Okay, so this is the where your UPF file. See, same VDD and VSS. If I click on this, if you select that particular thing, here it will going to be give the complete information of this particular supply side as well as supply net and everything else. Here we have the two ports. This is one VDD port and this is like VSS port, first which I was created. Then this is nothing but a supply set for the power. This is for the supply set for the ground function. Okay, and this is nothing but like supply net it will going to be called. So this is nothing but a domain name and everything else. Okay. So this is nothing but a for ground thing. Like this, the UPF will going to be replicated. That means what is the advantage over the front end to the back end is like in the back end, everything we can able to see like visually. The front end, just we are assuming the logic and we are writing and we are verifying through the inputs. But here, whatever the thing we are writing in the script format, we can able to see the visualization. That is the difference among the both. Okay. So here, see if I disable this one and if I apply, see, this is the top view, just simple way, without the implant like IMPL top block. So if I click on this one, here will be like auto apply. If I click, it will going to be show you like complete thing. See, now it is going to show the complete thing like this. You can able to see the different things also in the GUI mode. Once the foreplan is done, with the help of this command, I placed this all the input output ports like this all these ports like what are the above is there right? These ports I placed it through that command only. So here you can see like when you are in the in the floor plan stage, these are nothing but a standard cells exactly. So if I select here one thing, no, so this one standard cell for me. So this one standard cell and gate. Okay. So if I want to see internal logic of the AND gate, like where the AND gate is getting the input from where it is going output. So this is nothing but a fan out, where the single output is connected to the two things. Okay. So this is nothing but a OR and logic. This is a way OR gate with AND logic. OA cells will going to be look. This is nothing but a AO cells will going to be look. We saw the timing report, right? So same thing here, it will going to be replicate here. So this is the way you want to compare the timing report with this practical visualization and you want to understand this all the things. If I double click on this pin, I can able to see like where this output is connected for the which has a input and everything I can able to see like this. So until the placement stage will come, the standard cells will going to be placed in this origin only. Actually, it will going to be in this side. Like in this side, it will going to be look, but it was replicating in that inside. There will be no issue with respect to that both. Okay. So this is about the floor planning. So next is nothing but like power plan we will see. So this is nothing but your power plan. So see here, those are nothing but your rings. This is nothing but your ring. So this is nothing but your via. That means see, this metal layer is nothing but M8 metal layer. You can able to see in the left side. This layer is nothing but M8 and this layer is nothing but like M7. So between the two different layers, the particular via it was created here. So if you want to see the layers separately means see here you can able to disable everything. All the metal layers will going to be disappear. And here if I select only the M7, I can able to see here M7. Okay. See here what is the color of the M7 also it was replicated. And here M8. This is the M8 metal layer. The pattern and everything also is changing. So if I want to change the colors and everything also I can able to do here. Set the style M7. See here I can able to visual set like this also. See the color and identification, everything I can able to change for identification purpose. See here now there is a no via between the both. If I select the via here, then the via will going to be. See here, this is a M7 metal layer, this is a M8 metal layer. What are the two vias can be used to connect the M7 M8 is like M7 DMY is the one thing, via 724 is the another thing. These are two wires which can use it between M7 and M8. So that is the via here it was replicated. Clear? So this is the thing. And next is nothing but this thing. Give me a second. Like up to power plan, it is clear means then we'll see the placement. Then again, we'll jump into this tool. Okay. So in the placement, what will going to be happen like exactly? So whatever the standard cells now I showed you near that origin point will go and place here exactly within this citrus. I want to show you one more thing called as citrus. Okay, these are nothing but a citrus. In between the citrus, the standard cells will going to be placed. Okay. And while coming to the placement stage, all the standard cells, what are the things will going to be present at this core area? This all the standard cells go and place in within this citrus. Based on that, it will going to be decided. Okay. So this is the way the standard cell placement will going to be happen in the core area. So this is the main objectives of the placement stage. Like it will going to focus on wire length, routability, and performance, as well as the power and power distribution. So these are the few inputs we want to take for the placement stage, such as like technology file, netlist, HDC. Library, from the library, you want to take as a lib and left. Okay. These are things from the floor plan. So this is the main objective, the goals of the placement stage. Like we want to make sure that our main objective is like timing area and power optimization is supposed to make sure on conjunction it not supposed to occur. This is the thing. And this is the two techniques where we want to follow, like the placement stage we're going to be taken, like timing driven as well as the conjunction driven things. Okay. So this is the flow of the placement thing. So initially we are taking the inputs, then we are reading the based on the netlist, we are going to be do the global placement, detailed placement, and placement optimization. So here, this is the where the global placement is going to be look. Like it is not following any rules and anything else, just it is like as overlapping and everything. So here the legalized placement will going to be happen here. So under this optimization, it will going to be do like cell sizing and VT swapping, like LVT to HVT swapping, HVT to RVT swapping, and everything will going to be happen there. Okay, these are the various like techniques to optimize the timing area and power. With respect to the area, we are going to be use the things called as a resizing. Like this is the cell, this is the actually existing thing. It will going to be optimized like this, where the area will going to be reduced, as well as the conjunction we may going to be called a routing conjunction. This all the things. Those are called as a cloning techniques. Here the output is driving the 5 to 6 input pins. Now it is replicating with the two things, where the drive strength can able to increase it. Here buffering as well as here redesign fan in the tree like. So these are where it was arranged like. So it was arranged into this string. So it will take certain time for the to get the 4 inputs, and then it will after the shell delay it will going to be generate the output. But here is the same output and same logic it will going to be. Here the logical path is like 5 here, but here the logic path is like just a 4. Like some delay will going to be reduced here. With respect to the timing, decomposition and composition techniques we are going to be used. This is the like under logic is there. So under logic will going to be replicating like this with respect to NAND gates or AND gates. So these are swapping competitive pin techniques. Like few other techniques also will be used. So these are the major techniques which the tool will going to be do whenever you run the place after any commands. So while coming to the clock tree, here the main objective is like by following the certain two terms called as a clock skew and latency, it will going to be distribute the clock to all the sequential components properly. Here, this is the where the clock will going to be start at this point. From this point to the this is the sequential component where the clock will going to be distribute through like this. Okay, so skew is nothing but the amount of time taken by the clock signal between these two flip-flops. So latency is nothing but from here to here how much time it is taking. Within this, it was divided into two things: clock latency and source latency and network latency. This is nothing but a source, and this the distance is nothing but a network latency. So there is a one more thing is there called as the NDR rules, non-default rules. Actually, in the technology file, there will be like minimum width and minimum spacing, right? So other than that, if you want to maintain the more spacing or more width between the metal element, then we are using this NDR rules, non-default rules. That is nothing but a double width and double spacing, which we are going to be called. It will going to be this technique is used to reduce the crosstalk and electromigration effect. So these are the inputs for the CTS, technology file, netlist, and HDC, libraries, and everything. So these are where the CTS flow will going to be look exactly. Okay. And this is the way the clock tree network will going to be distributed with respect to insertion delay as well as the clock tree problems. Okay, so these all the things we will see in the tool directly. Okay. So this is nothing but uncertainty. With respect to the uncertainty, instead of the clock is arising at this point, it will going to be, it can able to arise before as well as after also. Where it will going to be impact with respect to the two terminologies. So it is nothing but a positive skew and negative skew. Positive skew means first the clock will going to be reaching to the launching flip flop first, and then for the capturing flip flop is called positive skew. Skew will go first for the clock will go first for the capturing, then for the launching means it is called as a negative. So here that local and global skew technique will going to be based on this thing, like shortest path and longest path. Based on that local skew and global skew, we are going to be decide, and we are going to be doing the optimization with respect to the two things. These are the various algorithms which we are going to be used in the CTS stage to do the clock distribution among these all the sequential components. So actually the algorithm will going to be look like this all. So based on the skew and latency targets, it will going to be used. So these are the things. So this is the output files which we are going to be get, like timing report, congestion report, and skew report, and insertion delay reports, and these all the things. So these are the techniques we are going to be used. Like almost all same techniques what we are going to be used in the placement stage, but with respect to the different format, like different operations, it will going to be target. So next is nothing but a routing, where the physical connections will going to be happen among them. Okay, so main objective is nothing but like skew requirement as well as the opens and shorts. So we want to make sure like there is supposed to be no opens and no shorts once the routing is done. And with respect to the DRV as well as the DRV violations such as max cap, max transition, and max fan out things. So this is the flow of this global routing, and track assignment and detailed routing will going to be happen. So in the global thing, like some rough connections will going to be happen. It will won't follow any rules and nothing else. So here it will going to be assign some tracks to the particular thing, and then it will going to be connecting like properly as per following the timing constraints, power constraint, like conjunction related things and everything. And based on that all the things, it will going to be connect. Finally, if the still it is violating or the any path means, then the search and repair stage will going to be find out that thing, and it will going to be fix that all the things. Is the way that global routing will going to be look exactly. So this is the way the detailed routing will going to be look. So these some algorithms is there how the routing will going to be happen. That is nothing but like Manhattan or standard tree algorithms. Based on the few algorithms, it will going to be happening. So these are the things which will comes under the sign off stage, like filler insertion. Like there we saw like some gaps between the standard cells, like after during the placement stage. So to fill the gaps, we are going to be use the filler cell insertion or metal filling insertion. We are going to be use with the help of tie up and tie low shells. We can able to control that shuts and opens on the particular power planning. If any channel cell is continuously driving the 0 or 1 means there the tie up, if it is a 1 means tie up cell will going to be placed like physical only cell, and tie down cell will going to be placed at the VSS place. So few analysis we want to do, that is nothing but a conjunction analysis. I will show in the tool now with respect to graph format and everything. And next is nothing but EM. Next is nothing but antenna file. So mainly this is the thing major part you want to cover as a PD engineer. So just I will show this all the blocks, everything, and we'll close the things. Okay. And we can give the mic access to them, like they can ask the questions. Parallel, I will show the things. Hello, ma'am. Ma'am, are you there?
Hello. Hello.
Can you give them the mic axis? Parallel, I will show the rest of the placement and routing stage for them.
Okay, okay. I have given.
Yes. Guys, if you have any specific doubts, you can ask, okay? Parallel, I will open the tool. Otherwise, it's bit
Hello,
lag, okay?
hello, sir.
Yeah, yeah, please.
Sir, I'm Tarun. Sir, I have a doubt that for how the power is distributed between for multi-level voltage design, sir.
So there you require the UPF, like first of all, you want to define like how many domains is there and which metal
Okay.
layer, like which power supply net and supply port is supposed to be distribute the power to that. And you want to use a different network like that is, wait, I will draw and I will explain this.
Okay, sir.
Yeah, see, for example, you can able to see the screen, right? See, so here, this is your floor plan. If you're going to think, okay, this is your core area. So here your core area is this much. So here
Yes,
you
sir.
have the two voltages if you think. This is your VDD, this is your VSS. Sir,
Yes,
VDD L
sir.
you are going to be called. This is your VDD. Okay. So where the VDD only come supposed to distribute power to this block. Where the VLL supposed to distribute power to this particular thing. Okay. So at that moment, what will happen? Like you are going to be write the power plant script in such a way that it's supposed to route up to here only. It's not supposed to enter into this domain. It has separate domain name. It has separate domain name. As per the domain name you want to write and you want to give the extensions as well as the blockages you want to use. So as per that, this metal layer with the help of the blockage, it won't enter into this one. Okay. Understood what I'm telling?
Yes,
So with the
sir.
help of
But
some blockage,
yes, sir. My doubt is, so for entire design, there will be s- common rails only, no, sir. Common rails, stripes.
rail, yes, rails also you can able to convert, you can able to specify, like you can able to specify for the particular domains.
Yes, sir.
You can able to
Yeah.
create more than one rail also.
Okay. Sir, is there anything middle between the multi-level design, sir? Like any
Like level
placement blockage or
shifters,
any type of cells are placed between the two type of designs,
some
sir?
like physical only cells will going to be placed, right? Multi
Yes,
voltage
sir.
cells such as level shifters you are going to be called
Okay.
whenever the, so that will going to be helpful for you to communication purpose between the two different voltage domains.
Okay. Yeah, got it, sir.
Any other
I
doubts?
have a question.
Thank you, sir.
Yes, I have a question.
Okay.
My question is that how we can connect two ASICs to different applications. Like if you talk about system on chip, we have one chip for one application and other for another application, and how in the system these both ASICs or different applications will interconnect, and how the buses will interconnect in the layout designing. If you talk
See,
about the
first
whole
of,
SoC.
yeah, if you are going to be speak about the whole SoC, if you saw the partitioning stage, right? So separate modules first you are going to be do. In the metal layers, there will be one more metal layer called as a MRDL. Okay, what the MRDL metal layer will going to be do like, it will going to be do the connections as per the connectivity between the two modules. Based on that, the communication will going to be happen in the SoC level. So there will be MRDL metal layer with the technique called as a feed through technique. They are going to be connect and they are going to be build the connection among the both.
Hello, I have a clarification.
Okay.
Well, am I audible?
Yes, you are audible.
Like now people are talking about AI integrated chip designing, right? So what are all the places that AI will be having role and it will cause impact? Hello, Murali sir, am I audible?
Yes, you are audible, please.
Yeah, like I completed, sir. I'm asking about usage of AI in this entire process. So to what level I have to master and where I can stop so that I can focus more on design or architecture kind of thing.
So what is the AI you are speaking about? Like with respect to what process? With respect to the stage automation or what?
Let us say we are talking about something called floor planning and all some floor planning
Okay.
algorithms we are talking about optimization. So like earlier you may be doing something manually. So like whether I have to use individual tools to optimize based on the log files or how it should go, like whether the tools entire tool set will be different.
See, the optimizations and everything will going to be happen based on the whatever the constraints you are going to be providing to the tool. Okay. What are the inputs you are taking to the tool? Based on that thing only it will going to happen. So you're not supposed to use like each and every stage different things. See, PD means you can able to use a single tool, but with respect to the AI is nothing but automating. So just there you are going to be give some certain specifications to your design. Based on that only the tool will going to be decide like what algorithm it want to use and how to do this floor plan, everything it will going to be decide internally only. Okay, so AI for AI also, first of all, you want to guide the things. What exactly you are required during the floor plan and everything else.
If I gave that
And
input
one more,
files, whatever you mentioned at
yeah.
each and every phase, if I am having something as some files kind of thing, whether you call it as a spec file or whatever it is, the remaining
Okay.
aspect I need not do manually. Is it? Am I correct? Is it the context?
See, that is the way already it consists of certain algorithms internally. If you give this basic input, with the help of this basic input, what are the predefined algorithms are they present in the particular AI or any automation tool, it will going to be continue the thing. So in the what is the one more advantage in the PD? Like if you use that only the mandatory inputs, that is enough. The basic floor plan, a basic power plan, everything it can able to do it. Okay, so for single domain UPF I told. So without UPF only without UPF also a single domain power planning you can able to implement it. If you require any specifically to design for your chip, then you want to specify that particular constraints and everything else. That is the thing
So
I'm
in
telling
that
you.
case, most of the aspect the AI tool will be able to take care.
Yes, almost all. But not specifically. If you want any specific optimization or anything else, you want to specify it. Like you want to
Huh.
target on the particular path, you wanted to you're not supposed to touch the particular shells, so you want to target only the particular shell, means you want to give that information. Based on that only it will going to be work out, otherwise it will be difficulty.
Okay. Okay,
Any other
understood.
questions?
So what is the
Isn't
difference
it?
between voltage domain and power domain and voltage area?
Okay, the voltage domains is nothing but like for the particular area, like what is the voltage, I mean within this particular area, what is the voltage of the, I mean, what standard cells are placing. I mean, what is the threshold voltage of the particular shell? Okay. Power domain is nothing but like you are going to be called what is the power you are going to be distributing with respect to the network and grid base and everything.
Means like as we know, power is nothing but voltage into area, right?
Yes.
So this how this voltage and power are separately they are defining.
So like how we are going to be tell like based on this power means like particular group of voltage areas or grouped together, they are going to be called as a power domain. That means where you can able to control that whether the power is supposed to be distributed to the particular domain or not. Okay. So mainly you can able to tell like to minimize the leakage power, we are going to be use this creating this power domains, or we can able to use this to control the dynamic power. We are going to be create the we are using this voltage domain, like based on the requirement and application, we are going to be create either power domain or voltage domains. Are you getting like what I'm telling? That means
Yes,
it is a group of logical circuits. Okay, we are grouping together and we are supplying the we are creating some certain power network and we are providing the power to that particular thing. Whenever we want to stop the power going to the particular module, we can able to control it. Okay, with respect to the leakage power consumption, we supposed to call it as a power domain. If you are going to be speak with respect to dynamic power consumption, you are going to be call it as a voltage domain based you want to go. Like level shifters and isolation cells, you can able to tell like with respect to power domains, you can tell as isolation. For voltage domains, you are going to be used as a level shifters. Is there anything other?
with respect to resulting in low power cells, right? Sir?
Like?
Low power cells you're telling, like retention cells, those things. Right?
Yes.
Isolation cells, those things. Sir.
Isolation cells and level shifters.
Okay, so
Retention shell is like for the memory backup, we are going to be using that one.
So another thing you told that just now MRDL layouts, you have some technique. What is the technique name, sir?
MRDL will be there. So whenever like the top level integration happening between the subblocks. So there we are going to be use the MRDL. Metal redistribution layer is the thing. Actually, we have that M9 plus MRDL metal layer, but in the subblocks and all everywhere we'll use up to M9 only, not MRDL. We are going to be ignore that metal layer because of the top level integration will going to be happen with the help of this thing by using a feed through technique. That means from top block to down block, if is there any connection also, it won't interrupt any other connection in between them with the help of that technique.
So like block to block connection, we need to use this MRDL layer.
Yes, in the top level.
Fine.
Next, any other questions?
In the case of chiplets also, this is the same MRDL layer will be used.
Where? Come again.
In chiplets.
In chiplets.
Yeah.
Can you be bit specify that question?
It is a kind of slicing different functional modules into multiple SOCs kind of thing.
Okay. Want to see that. Okay. I am not sure with respect to that. Like in the chiplets, what they are going to be used exactly. Any other questions? So server is like going on a rub. So you understand like how to do the floor plan and power plan, right? Is there any other questions?
Yes, sir, just a generic question. Will
Yeah.
this presentation be shared along with the recording? It was having
This
really
question.
good information.
This question will going to be answered by ma'am. Like I'm not sure with this. Ma'am, can you answer for this question?
Because I also missed the
Mostly-
class yesterday. The first session was we waited for 2 hours, and the evening class I could not attend. So
Okay,
both
understood.
recorded sessions of yesterday today be shared along with this document PPT. That would really be great and helpful.
Okay. Ma'am, are you there? Just a minute, guys. Ma'am will give you some clarity. I will think that. Is there any other doubts with respect to the technical means we can able to discuss? So rest of the thing like with respect to this recording and what is the brochure and everything else, ma'am will going to be discussed. Okay.
So this macro placement, we should follow the hierarchy, or we can distribute the macro hierarchy and place the macros.
No. We want to follow the macro hierarchy like as a grouping. Okay, you want to follow that macro grouping technique. Okay. So like those who what are the macros have the connections, you want to place near to each other only. If you place like if you are going to be distribute them, there will be going to be a chance for like crisscross connections, this kind of problems, right? So then the routing will going to be impact. Indirectly, it will going to be affect for your timing and everything else.
Means like
So
in
you want
Orcota we have 40 macros now. So in that
yes,
I go one hierarchy 16. In that 16 again another four are there. So we can split
yes.
those 4 separately and these
No, no, no.
12
See
separately.
what
Can we do that like that?
see whatever the thing is with respect to like which suppose you supposed to follow the Flyrane analysis only. Okay, if you distribute also there is a no issue, but it's not supposed to be impact on with respect to the conjunction and timing. You're supposed to make sure that and you want to distribute it. Not like as like blindly, like with respect to that, which it's not supposed to impact on the what is the analysis we are going to be doing in the further stages. Without impacting on the further stage, you can able to do that.
Sir, are you working in any company?
Yes,
I mean, which company, sir?
we're not supposed to mention that all the things here. Okay, so as the online things, these are nothing but confidential few things. We're not supposed to mention that exactly things and all.
Okay, sir.
Is there any other than this?
Sir, does
Yeah,
the
please.
industry expect as a physical design engineer, do we need to learn compulsory like Verilog and VHDL?
If you are going for the front end, that is important. Like Verilog or system
No,
Verilog, like few
I'm interested in physical design, not in
physical design
RTL.
means okay. Then you want to know the basic syntax of them. That is enough. Not like deeper. Just you want to know, like I
But
told you know, with respect to PD perspective, what you want to learn.
yeah, sir, I'm interested in layout. So I don't need to learn Verilog and VHDL, right?
No, no,
Is
no,
that right, sir?
not deeper. It's not required. If you are
But
going to be
we
interested in the
need
PV,
to know about scripting, right, sir?
that is sticky scripting, right?
Okay, sir.
Okay, guys, the
Thank you.
questions are over here.
And
So we
hello,
are
ma'am.
going to conclude.
Yeah,
Yeah.
here there is a question for him. Like someone asked the question regarding that recording will be available or what?
Yes, we are going to provide the
PPT.
recorded session. Yeah, we will provide the recorded session. I will update you in the Instagram. Please do follow the Instagram page. You will be getting the recorded sessions there.
And PPT, ma'am. PPT.
Through Instagram, ma'am.
Sorry?
Ma'am, will you send the record session through mail or somewhere else, ma'am?
Recorded sessions.
Can you send through mails, ma'am?
Actually, we will put all these things in a drive link and we will send in drive link.
Okay.
Yeah.
Okay, ma'am.
At least
Thank
for
you.
those who have registered
Please
for this,
share a PPT
please
also,
forward.
ma'am.
We will share the PPT, recorded sessions, everything in the drive link. Okay. And also, if you are looking for the training for physical design, we are going to start a new batch in July 1st week onwards. So this is our course curriculum, physical design course curriculum. These are what the modules we are going to cover in online and offline. Okay. So the module 0 will be the introduction to VLSI, where you are going to learn entire VLSI concepts like what is VLSI, what is the history of VLSI, present generation technologies, what is a nanometer technology, and why do we use CMOS technology, FinFET, GAFET technology for transistor fabrication, and what is the difference between ASIC chips, FPGAs, SOC chips, what are the exactly functional block diagrams available in the SOC chips, everything we are going to cover in module 0. And coming to module 1, we cover advanced digital logic design, where you are going to learn not just theory, total practical things you're going to learn, where it will be helpful for interview preparation. And 1.5 month, it's almost 1 month for PD. We are going to discuss Verilog HDL for RTL design. Then 3 months for physical design flow. Both theory and practical lab sessions will be covered with the Synopsys and Cadence tools, and 2 weeks for scripting language, and remaining is for RTL to GDS projects and major projects in the PD flow. Okay. So for full process, and we are also going to cover SOC level design concepts, which are most useful for the freshers. You need to exactly know the SOC design concepts also, because that is what exactly the industry use. And we are going to cover aptitude logical reasoning skills also, because these are most important if you are interested to crack product based companies. And not only product based, for service based companies also, in every entrance test they will ask the aptitude and logical questions. Okay, we are preparing every material, every assignment, every test as per the industry standards, how exactly they ask in the interview questions. That's why our students are able to crack the jobs very easily. We are training every weekend on there will be weekend tests on every module, okay, which includes the logical questions also. So this is what our curriculum. We will share you the curriculum for in the mail also. For more details, please visit provilogic.com, where you will be getting the course curriculum modules for VLSI and embedded systems. And I already shown you, right, our LMS portal, how we give the access for our students, where you will get the course enrollment details here. You need to check in and check out, like attendance is mandatory, and your learning progress can be verified here, and how many courses you have enrolled, and what are the questions you have, how many tickets you have raised. And there will be course sessions, online course sessions are available here in every module, and there will be materials, assignments, everything will be provided, lab sessions, and interview preparation questions, most important. And there will be weekend test, both theory and also practical, and you need to submit all the assignments here. And there will be attendance. We will check the attendance of every student, and we will update you. If you need any leaves and all, you need to take the leaves, everything here. And there will be announcements here, whatever the company's openings are there, or you need to clear the assignments, or you need to attempt the weekend test, we give the assignment announcement here. And if you have any doubts and all, you need to raise the ticket. And finally, in the 6th month of your training period, you can upload your resume to our placement cell, so that based on the requirements of openings, based on what companies you are eligible, like if you are IITs and NITs, we can try directly for product based companies. If you are IIT also, we can try for the product based companies. If you are normal company, normal colleges, we can try for the service based companies. Like based on your resume category, we provide the placement opportunities. Okay, so where you are going to upload your resume directly to our placement cell. So this is how our learning process in online. Coming to the offline, in offline there will be sessions from morning 10 to evening 6. Morning 10 to evening 6, you will be here, and you will be learning with the mentor guidance, and there will be trainers available here. Almost 9 to 10 hours the trainers will be available here. So online sessions are very strict. We maintain very strictly attendance, everything, and even weekend sessions. And some students have very low communication skills. So for them, we provide the PPT presentation, group discussions, everything. So this is our learning process. From 6th and 7th month onwards, 6th month, by 6th and 7th month, you will be going to complete the training. And next month, the whole interview preparation will be there, where you will be involving in mock interviews, mock tests, everything. You will revise every concept properly to attempt the interview, and then you will be eligible for the placement. Okay, from 8th month onwards, you will be eligible for the placement, and we provide at least 4 to 5 opportunities for every student. Every student we provide 4 to 5 opportunities, so you will get the chance to crack the job in that opportunities. Okay. And coming to the placements wise, as of now, we have 80% success rate in placement. And also we are going to start the service-based company soon from Provilogic. And so whatever our trained students are there, we are giving the stipend-based internships and job opportunities for our students only. We are not taking any outside the students for our service-based company.
Ma'am, present I have enrolled in ASIC Design Verification Provilogic.
Okay.
Ma'am, in 2 to 3 weeks, in 2 weeks, the digital electronics is getting over.
Okay.
Then they will have a Verilog, ma'am.
Yes, Verilog will be having, and you need to attempt the assignments also. Are you attempting the assignments and submitting there?
Yeah, ma'am. Yeah, ma'am.
Okay, okay. So everything the trainer will take care, the doubts, everything and all. Verilog is going to start immediately after digital electronics. After digital electronics, there will be mock interview for everyone. So after that, Verilog is going to start. Guys, any other doubts you have?
Ma'am, I was just checking previously. I think I missed that. The recording of yesterday and today will be shared to us along with the PPT which sir was
Yes,
showing.
yes, we will upload all in one drive. Drive link will be shared to you.
Okay. The PPT was really helpful. So thanks to you and sir. It was good. Thank you.
Okay, okay, sure. Thank you. Thank you. We will update the recorded sessions in Instagram. Please do follow Instagram page. We will send the drive link there.
Okay, ma'am. Like it will be mentioned in bio, and we have
Ma'am,
to
I
get
don't
from there,
use
right, ma'am?
Instagram. So can you put it on the emails, please? If you could, that would be best. Because Instagram, I don't
Okay.
use. Thanks.
Okay, okay,
How
sure.
how do we get from Instagram? Do we have to DM
Yeah,
you
you
like?
need to DM. We will send you the I will add a video there. If you do
Okay.
comment, we will send to the specific people only, not to all.
Okay.
Because mails means we got nearly 3,000, 4,000 mails. So all 4,000
Okay.
mails we should not send. Only whoever interested people are there, only those people we send.
Okay, ma'am. What about the certification, ma'am, for this free workshop?
Certificate we give by next week, by next weekend.
Oh. Okay.
Ma'am, but then how will you deal
Can you
my
share
case
Instagram handle?
if I don't use Instagram, ma'am?
Sorry?
I don't use Instagram, so how do I get this
You
link?
just tell me your name, I will note down.
Suresh.
Your mail ID.
Yeah, suresh.rx@gmail.
Suresh?
Suresh.rx
Okay.
at
Okay.
gmail.
Yeah, we will send to that.
Thank you.
Ma'am, I too
Ma'am,
don't
please
use
share your Instagram handle, ma'am. Ma'am, please share your Instagram handle here in the group, in the chat.
Provilogic. You can search Provilogic.
Ma'am, can you share that certification link again?
I already shared in the chat box, right?
But can you reshare it again?
Okay, just a second. Those who are already fill, no need to fill again, just fill only one time.
Ma'am, I too don't have Instagram.
If you don't have Instagram, just fill this chart, this again. Just in name, just put recorded session. We will check. Okay, I have sent in the chat box. Please look into it and share your details for certification. Okay. Okay, guys, hope you enjoyed the sessions and I think you got the technical skills from the session. We will conduct more sessions in Provilogic workshops and webinars in future. Every weekend, we will get industry experts who have nearly 10-15 years experience in PD, embedded systems, and ASIC design verification. So we will update everything in Instagram, LinkedIn, and YouTube. So for more details and updates, you can follow up our pages for future updates. Okay. If
I'm
and you
2020
can
pass
share
out. Can
the
I
links.
apply for this course?
Which year passed out?
2020. Rebellion.
20?
2020.
2020. Yeah, you can apply. You can apply. But design verification
Regarding
course would be best. I will suggest design verification course only, not physical design.
Ma'am, like any specific reason? No?
A specific reason means, openings will be more for design verification. We can cover that experience with the more advanced projects. But in industry, if you put a fake experience with PD means they will ask more advanced questions and advanced node technologies. So we cannot work as of now with advanced node technologies, right? That's why design verification means so there will be a lot of openings. We can jump easily.
Fine, ma'am.
You're very interested in PD, then you can choose PD also. I don't restrict, but yeah, design verification is good.
Yes, fine.
Ma'am, is there any internship programs are offered through ProLogic?
Yes, 2 months and 3 months internship programs we are offering. It's already going on for DV and PD.
And how to apply for that, ma'am?
You can contact to our number. There are contact numbers in LinkedIn. It is available. Instagram. It is available. YouTube available. Google also it is available. Even our website here. I can share my screen.
Okay. Yeah, ma'am.
In website also our contact number is available.
Ma'am, what modules you cover in internship program?
There are RTL design internship and physical design internship is there. In RTL design, we provide Verilog, HDL, digital electronics and projects. Verification means we provide a system Verilog and projects like that. Go to
In PD?
Provilogic, and here you will find the contact details. This is what our number. In PD also same. CMOS design, static timing analysis, digital logic design, and entire PD flow.
Ma'am, for this session, when recording will be available?
By evening.
Will we get in our email ID if we have registered through that?
Here some people are shared, right? We can share to your email, but email means it takes some time. Tomorrow evening like that we can share in email.
Okay, ma'am.
Okay. Okay, then thanks for your time. I really appreciate for your time. Okay. In future, if any workshops are there, please refer to your friends and family people. Okay, then thank you all. Have a good day.
Thank you, ma'am.
Thank you, ma'am.
Thank
you, ma'am.
Really thanks for your
Thank
time.
you, ma'am.
Thanks for spending your time with
Thank
our
you, ma'am.
students.